my dear students, happy new year to all of you, and I wish you all the best for your upcoming physics exam. So today I am going to discuss the all the important questions that is going to come in your PU2 pre-board exam, that is tomorrow for all the students, and this will be consisting of all the questions chapter wise. Okay, so we will be discussing questions chapter wise. Each and every chapter will be covered, including numerical questions. So how we will start? We will start with MCQs, and then we will show you all the important questions. I am not going to discuss all the important questions, those are already discussed in separate videos, so you can go check that out, but I will give you the questions. So if you are wondering what questions to prepare and if you want to know more about them, that will be given here, and also I will be solving numerical questions where most of you struggle. So MCQs and numerical questions, that is the hindrance for you scoring above 60. Right, so that's what I am going to do today, and also I will give you the important fixed questions that is going to come from the chapters. So first chapter that we will start with electric charges and fields. Okay, so first is charges are conserved for dash system: open system, isolated system, any system, no system. Hello Shiva, hello Blackie, good afternoon. Vashu Gaura is saying thank you too also for joining the live session. So now try to answer these questions. These are only specifically for you. I will wait, I do not have too much time. Obviously all of you have a paper tomorrow, so I will give you some time to answer those questions. Initially maybe a little bit more. Once all the students are coming in, I will go a little bit faster, right? Aluge Depo is saying B killer gaming. I will try to complete it in 2 hours. Okay, that is my target, to complete the video the session in 2 hours. It might go little more than 2 hours, but it will be, I will try to complete it by 6 p.m. okay, so if you watch, you just came back from exam, so now if you invest 2 hours, your 60 plus marks will be guaranteed. Then you can go and revise. Okay, remainder of the day you can revise. So if you answer quickly, I will finish it quickly. So that is up to you as well. So obviously isolated system, charges are conserved for not any system. Remember, it is not conserved for any system. This is not correct. Correct is isolated system. Only for isolated system charges are conserved. Next, SI unit for surface charge density is, SI unit for surface charge density, surface charge density. So the unit based questions are very common. Okay, yes, option B was correct. Now answer the second question. Second question is also option B, coulomb per meter square. So be careful, again it is not coulomb per meter cube, it is coulomb per meter square. Surface charge density is coulomb per meter square. Line charge density is coulomb per meter, and volume charge density is coulomb per meter cube. So all three units are very important. Next, SI unit of electric field. SI unit of electric field. So very interesting. Newton coulomb, Newton per coulomb square, Newton per coulomb, volt meter. Now answer the third question. TDF, I have already, TD Inferno, I already informed that it will be within 2 hours. I will try to complete it within 2 hours, but you have to answer the questions fast. Okay, now next question, SI unit of electric field. So SI unit of electric field can be given in 2 units. One is obviously from Coulomb's law, which comes out to be electric field is force per charge, and another one is from electric potential, so it will be dV by dl. Okay, minus. So this, from this you get Newton per coulomb, from this you get volt per meter. Both are SI unit of electric field. Both you have to remember. Here it is Newton per coulomb, that is Newton coulomb to the power minus 1. Okay, so these are the 2 units of electric field. Next, the angle between dipole moment and electric field at any point on the equatorial plane is. So what is the angle between dipole moment and electric field at any point on the equatorial plane? So here is the dipole, plus q minus q, and what is the angle between dipole moment? So dipole moment is from negative to positive. What is the direction of electric field? will this class be sufficient, sir? Yes, Gauri Krishna, it will be sufficient, but you have to prepare after the class is over. You can go check one more long form lecture that I have done. That will be sufficient, including everything that is sufficient. But yes, this is just like a preparation for your upcoming exam, right? Standalone this lecture is not sufficient, but yes, it will be very helpful for you. The remaining portion, if you have certain level of preparation, then this will be obviously sufficient. If you have watched my previous videos where I have discussed the questions, I will give you the questions, but answers you have to figure it out. I have done other videos where the answers are also given, so do check that out as well. So the angle between the dipole moment and the electric field is electric field for a dipole moment and electric field for the equatorial plane. They are in the opposite direction. So opposite direction means dipole moment in this direction, electric field in this direction. So angle is 180 degrees. So correct answer is option D. Okay. Correct. Everyone is correct. Not 90 degrees. Chandrika Sagar, not 90 degrees. Be careful. It is 180 degrees. Now again another question, electric dipole placed in uniform electric field is unstable if the angle between the electric field and the dipole moment is 0, 60, 90, 180. Now from there you can easily eliminate 60 degrees. Generally does not come out to be 60 degrees, either 0 or 90 or 180. Three of them can be the answer. Which one is correct? Now for that I will give you one hint, that it is unstable when torque acting on the dipole is 0. Torque unstable means torque acting on the dipole is maximum, not 0. Torque acting on the dipole is maximum. So what is the expression for torque? Torque is given by PE sin theta. So when the torque is maximum, the dipole is most unstable. So when is the dipole is unstable? When the torque is maximum. So when the torque is maximum, which at what angle? Is it at 0 degree? Is it at 180 degree? Obviously no, because both cases torque is 0. So unstable means it is 90 degree. It is not asking about unstable equilibrium. They are simply asking the dipole is unstable, not stable. Equilibrium, unstable equilibrium, this can be considered unstable equilibrium. Okay, this is stable equilibrium, but completely unstable is at 90 degree. Okay, at 90 degrees it's completely unstable. Yes, C is the answer. Next, before continue, just wanted to tell you that ABHYAS KCET test series 2026 is live, and as per your demand we are also giving you 35 tests, also chapter wise KCET PYQs, real KCET exam pattern and timing. So if you want to practice questions in real time, that is 60 minutes for 60 questions, so you will get that opportunity in KCET ABHYAS KCET test series. No other testing platform gives you that, and the price is kept only for 1499. Here you will get 35 tests, also chapter wise KCET PYQs for your practice. Okay, so along with your PU2 preparation, you should also prepare for KCET exam. Already more than 1000 students have registered for it, so don't be late. Join today if you have not yet joined. Right, now let's look into the fixed question from this chapter. State and explain Gauss's law, write Coulomb's law, state and explain Coulomb's law in vector form. Sketch the electric field lines for force due to a point charge. If Q is less than 0, Q greater than 0. Define electric dipole moment, mention its SI unit. Torque and electric dipole at a small derivation. This is also important. Properties of charges, super important. Properties of electric field lines, another super important. These three questions you have to prepare. Remaining questions and this one. Okay, these are the most important questions from this chapter. Electric field due to a dipole axis and equatorial plane. Electric field due to a charge straight long wire. Electric field outside a charge spherical shell. These are the important derivations from this chapter. Now if you are not getting a derivation from this chapter, what you are going to get? You are going to get a numerical. Either a numerical or a derivation will come. So next time for us to solve some numericals. Numericals are very difficult for all of you. So I have handpicked some numericals which are very important. Three charges each equal to +4 nanocoulomb are placed at the three corners of a square of side 2 centimeter. Find the electric field at the fourth corner. This is very important and very common question which repeatedly comes in pre-board exams. Okay, This type of questions are very common and repeatedly comes in pre-board exam. So 3 charges, all of them are plus 4 nanocoulomb, plus 4, plus 4, plus 4. All of them are kept like this. Now they asked you find the net electric field at this corner. Okay, so here you have to find the net electric field. How to do that? Every side is 2 centimeter. 2 centimeter and 2 centimeter. Okay, so if you consider this plus 4 nanocoulomb charge, what will be the direction of this electric field? Electric field will be always pointed either outward or pointed inward. For positive it is outward, for negative it is always inward, right? These are the 2 directions that you have to be careful about. Now due to this positive 4, it will be again outward direction. Okay, so these 2 are outward, and what is the angle between them? Angle between them will be 90 degrees. And if you see that their magnitudes will also be equal. So if this one is given by say E1, this one will also be E1. Why? Because both charges are same, distances are same, so the magnitude will also be same. But this plus 4 is making some difficult choices. This is making our life slightly difficult because this is along this direction. Okay, and if you see that this is along the diagonal, and this is actually bisecting this angle into 2 equal angles, 45, 45. And because these 2 values are same, the resultant of these 2 vectors will also be along the same diagonal. Do not calculate individual electric field and add them, that will be wrong. So you have to calculate these 2 electric fields first. Okay, so E1, what is E1? Formula is simple, K Q1 by R square. Okay, what is K here? K is 9 into 10 to the power of 9. What is Q1? Q1 is 4 nanocoulomb. Nano means 10 to the power of minus 9. And distance is 2 centimeters. So whenever you see centimeter, you have to add 10 to the power of minus 2 to convert it into meters. Don't go for decimal substitution. Decimal substitution can be confusing because many of the time you have to take square, and students do make mistakes while doing square. You will try to avoid calculators as much as possible, because even if you are using calculators, you may make mistake. You use the calculator only for the last step. Okay, use the calculator only for the last step, otherwise try to avoid calculators as much as possible. So 10 to the power of 9, 10 to the power of minus 9 cancels. You get 9 into 4 divided by 4 into 10 to the power of minus 4. 4 cancels, and we get 9 into 10 to the power of 4. This is the value of one of them. Okay, Newton per coulomb. Now, sir, is it sufficient if I practice all the questions you had given in your earlier? Yes, of course, that is sufficient, more than sufficient. That is more than sufficient. So blueprint it says there is only one numerical and MCQ from AC chapter. Yes, so in blueprint they have not mentioned whether it will be a numerical or a 5-mark long question, but from the previous year's experience we can say that it will be a numerical question. Okay, in this year's blueprint they have not separated from which chapter you are going to get numerical, from which chapter you are going to get a 5-marker long question. Okay, generally last year it was very confusing. They give 3 different blueprints for 3 different model papers. At least they have fixed that problem, so they have given a consolidated blueprint. Okay, a consolidated blueprint wise almost blueprint is same, some here and there happened, otherwise it is almost same. Killer Gaming, yes, it will be provided. The PDF of this lecture will be provided after this lecture is over. So join our WhatsApp channel if you have not joined it, and if you have not joined, subscribe to our channel. Don't forget to subscribe to our channel as well. Okay, sir, is it sufficient? I already answered your question. And Summer is saying thank you also for joining. Tanisha is saying, sir, is blueprint says there is only one numerical. Yes. Okay, all the questions I have answered. Now let's move on. So in between the if you have any doubts, post it, wait for some time. I will try to answer it once I am free. Okay, I am doing live class as well as I am taking your answers. Okay, so don't be disappointed if I do not answer your questions immediately. Okay, I will answer. Just hold on for a few minutes. I will answer all of your doubts, all of your questions. Okay, so 9 into 10 to the power of 4 Newton per Coulomb is the net electric field along this direction and in this direction. So the net electric field of these two is, say, E1 net. What is E1 net? Here we have one vector in this direction, another vector in this direction, and they are perpendicular. Both of them are equal. If both of them are equal, okay, their net resultant will be simple E1 root 2. Okay, this is the shortcut formula. If you want to know the longest formula, this is nothing but E1 square plus E2 square plus 2 E1 E2 cos theta square root. Okay, here cos theta is 90, cos theta is 90, cos theta is 0. So it will be square root of E1 square plus E1 square. That is how you get E1 root 2. So net electric field will be E1 root 2. So that is 9 root 2 into 10 to the power of 4. So it is not very difficult question if you practice it at least once. Now what about the electric field due to this? We have calculated electric field due to these 2 points. Okay, what about this one? Say E2. What about this E2? So E2, to calculate E2 we have to know this distance. What is this distance? This distance will be A root 2. Diagonal of a square is given by A root 2. Okay, geometry, you have learned it in your lower classes. So A root 2 is the diagonal of the square. Now A here is 2 centimeters. So E2 will be K, charge is same. If you see that charge is same, but distance is different, so it will be A root 2 whole square. Okay, or 9 into 10 to the power of 9 into 4 into 10 to the power of minus 9 divided by 2 root 2 into 10 to the power of minus 2 whole square. So everything is same except we have a root 2 extra over here. Now take the square, obviously this cancels, we get 9 into 4 divided by 4 into 2 into 10 to the power of 4 minus 4, sorry. Okay, minus 2 minus 4. So 4 cancels and we get 4.5 into 10 to the power of 4 Newton per Coulomb. So now you can add these two electric field because both of them are in the same direction. This one and this one, both of them are in the same direction. So only now you can add these two electric fields. So the net electric field is basically addition of this 9 root 2 plus 4.5 into 10 to the power of 4 Newton per Coulomb. Okay, you can use the calculator to calculate the value of 9 root 2 and then add it to get the exact value. Exact value will come out to be 17.22 into 10 to the power of 4 Newton per Coulomb. Don't miss out on the unit. Without unit, 1 marks will be deducted. Okay, so 17.22 into 10 to the power. Sir, will you do questions and answers also? Who is heart? Pavitra, I will give you all the questions. I will solve MCQs and numericals. Okay, I will solve the MCQs and numericals, but I will give you all the questions that is going to come. Okay. Good evening, Smoothie, I can't pronounce your name. Sir, today chemistry question were very unexpected, not from the given questions. Ash, it can happen, it varies from district to district. Some district their questions were actually exactly the way ma'am taught. Some district it might happen, but as we try to give you the most expected questions. In some district, if the paper setter decides that I want to give you some new style of questions, it might have happened. Okay, so let me know which district you are from. Flute Soul is saying I will get 60 plus in physics. Very good. Hello Pavitra. Hi Kunal. They are telling questions and answers. Sir, maths and biology, Rahul Kohli, math, I don't know about math. Biology will be tomorrow, okay? Biology will be tomorrow, maybe maths will be on Monday. Conducting sphere of radius 10 centimeter has an unknown charge. If the electric field 20 centimeter from the center of the sphere is 4.5 into 10 to the power of 3 Newton per Coulomb and points radially inward, what is the net charge? So be careful when you are solving the numerical questions. Be careful. I am sure that you will be able to answer the long form questions. Long form questions I am giving in the video also, and I am sure that if you are watching my videos, you will be definitely able to answer those questions. The problem is numericals and MCQs. You also know that fact. So that's what we are focusing mainly, right? So here it says that electric field due to a charge sphere of radius 10 centimeter. But we are trying to find at a distance 20 centimeter, okay, and the electric field is given here, E equals to this value, and it is pointing radially inward. That means it is going in. Now going in means what? Going in means what is the type of the charge? Charge must be negative. The charge must be negative. So radially inward does not mean anything. It means that the charge is negative charge. Okay. So electric field, what is electric field due to a charge sphere? So electric field due to a charge sphere outside the sphere is always same as a point charge kept at that point. So if you keep a point charge and if you try to find the electric field, whatever electric field you will get, the same electric field you will get for a charge sphere when you are calculating outside. Inside the sphere, electric field is 0. If it is a conducting sphere, electric field inside is 0. Outside you can treat the entire charge is located at the center and treat it as a point charge. Now what is the formula for electric field due to a point charge? Same formula, KQ by R square. Okay, don't worry, you have to write this formula. This is the electric field formula, right? And K is 9 into 10 to the power of 9. Q is given by, not given, so Q we have to write minus Q, or let me not write minus Q over here. We will take the electric field as negative. Okay, Q divided by R is given 20 centimeters. So whenever you see 20 any centimeter, you have to add minus 2, 10 to the power of minus 2. This has to be added to convert it centimeter to meter, and that value is given 4.5 into 10 to the power of 3. And remember, this is inward, so we will take a negative sign. Okay, the negative sign represents the electric field is inwards. Okay, now you have to simplify this. So 9 into 10 to the power of 9 into Q divided by 4 into 10 to the power of minus 2. So what I have done, I have adjusted this 0 with 10 to the power of minus 2. So it become 10 to the power of minus 1. Now doing the square, we got 4 into 10 to the power of minus 2. Minus 4.5 into 10 to the power of 3. Now do the cross multiplication. We get Q equals to 4.5 into 4 into 10 to the power of 3 into 10 to the power of minus 2. Okay, so everything multiplied over here divided by 9 into 10 to the power of 9. Okay, so what is 4.5 into 9? You can cancel it by 2, and you can cancel 2 with 2 as well. Okay, so what you got? You got 2 into 10 to the power of 1 by 10 to the power of 9, or 20 into 10 to the power of minus 9. So it will be 20 nanocoulomb. So the charge is 20 nanocoulomb with a negative sign. Don't forget the negative sign, because it is electric field is inward. So minus 20 nanocoulomb is the correct answer. Okay, if you want, you can keep the answer as this value as well, 20 into 10 to the power of minus 9. That's fine, but don't forget to add the unit. If you are keeping it here, it will be coulomb. If you are keeping it here, it will be nanocoulomb. Next question. A positively charged spherical conductor of radius 0.1 meter produces an electric field of 1.8 into 10 to the power of 3 Newton per Coulomb at a point P distant 2.2 meters from its center. Okay, another charged spherical sphere. Calculate the magnitude of the charge present on the spherical conductor. Also, find the magnitude of the new charge produced at the same spherical conductor if 5 into 10 to the power of 10 extra electrons are removed from it. So, first we have a charge sphere. Charge sphere, okay. In today's chemistry paper, there were 4 to 5 questions from model paper. Yes, Pranjal, there will be some questions from model paper as well. High chem paper is same for all district. No Shushmita Patgar. It depends from district to district. From, for example, Bangalore North and Bangalore South are different. Okay, all the districts, they have a different code. Okay, based on your code, there will be different papers. But questions are usually 50 to 60% questions are common and same. Okay, I can tell you from the experience of last year's paper analysis. Once all of your papers are done, okay, we will probably sit together and we will find out all the papers, all the district papers, and then we will try to analyze how much question was same, how much question was different. So based on that pattern, we can actually predict what are all the questions that is going to come in your board exam. Okay, that is only possible once we get all the district board papers and once we have collected all the data. Okay. Right. Now here again similar question. Here the electric field is given positive. Okay, so we will use the same formula, KQ by R square. Same formula. Electric field is always given by the same formula. So from here you can directly write Q equals to, let me solve it slightly differently, E R square by K. Okay, so E is given, R is given, and K is known, so we can calculate Q directly. So what is Q? Q is here, electric field is 1.8 into 10 to the power of 3. R is given here 0.2 meter. This is radius, by the way, don't take this distance. Okay, you have to take the actual distance, 0.2 square divided by 9 into 10 to the power of 9. Okay, now let's simplify. This will be 0.2 and we get 0.2 into 10 to the power of 3 into 4 into 10 to the power of minus 2. Same, almost same question. Only thing is the second part of the question. Okay, so it will be 0.8 or 8 into 10 to the power of 9 minus 9. Okay, so it will be 8 nanocoulomb. This question is taken from your model paper. This question I have particularly taken from your model paper. This style of question is expected. First question and this style of question, both are very, very important. Second part is also find the magnitude of new charge produced on the same spherical conductor if 5 into 10 to the power of 10 extra electrons are removed. So already it had 8 nanocoulomb. You have to convert this amount of electrons into the amount of charge. So how can you do that? You have to do this is say Q. Now additional Q, say Q dash. This much extra you are adding by removing this much amount of electrons. So if you are removing electron, that means the object is becoming positive. So you have to add the charge because it is already positive. The new charge is also positive. What is the formula? From quantization principle, the formula is N into E. What is N? N is given here 5 into 10 to the power of 10. And E is 1.6 into 10 to the power of minus 19. So it will be 5 into 1.6 is 8 into 10 to the power of minus 9. So another 8 nanocoulomb is added. Positive charge, another plus 8 nanocoulomb is added. So total charge now is, the total charge is 8 plus 8 equals to 16 nanocoulomb. So the total charge here is 16 nanocoulomb. So first it was 8 nanocoulomb, second it was 16 nanocoulomb. So do you think physics paper will be tough? Among it depends on the preparation level. If you have prepared all the questions, it will not be tough. Okay, numerical questions can be tricky, but if you practice the numericals that I am doing in our lecture today, then you will not feel the pressure. Okay, otherwise physics paper is very much predictable. Last year what happened, you know, one question in the board exam, in one question there was a small typing error, and there was a lot of students make mistakes based on that typing error, but actually the question was easy. Will this question come for tomorrow? Yes, obviously that's what I am expecting. Is paper leaked? No, paper is not leaked. It is from my experience. I am telling you that this style of questions are important. Exactly same questions may not come, but this style of questions are important. Okay, you might find some district that a completely different style of questions are coming, but yes, if you practice all the questions that I am going to do today, then definitely you will find at least 2 of the numericals that you can answer. Okay, that is my guarantee. The angle between equipotential surface, basically you do not mug up the problem. You have to understand what formulas, what concept we are using. That is important. Okay, you do not mug the exact question. I have seen that some students do that, especially for competitive exams. Okay, they mug up entire thing and the question is asked a slightly different way and they are not able to answer those questions. So do not mug up the questions. Okay, just understand the principle, understand how it is being solved, what is the formula used, what are the concept used. That is important. The angle between equipotential surface and electric field is. So what is the angle between equipotential surface and electric field? Someone please answer. By the time, let me have some tea. What are you teaching? Will that come tomorrow's exam? Nitin, I already told you multiple times, I am not teaching you exact questions. I am just teaching you the probable question. These are not paper leaked, these are the probable questions. Okay, paper leak is not possible. That is not in my agenda as well. I am not here, I am a teacher. I do not support any leaking or anything. Okay. The angle between equipotential surface, someone answer. Yes, question 90 degrees. 90 degrees, equipotential surface is 90 degrees. Equipotential surface and electric field is 90 degrees. Okay, if paper was leaked, I will only be solving those questions, right? But I am not solving the only one question. What is the total charge on the parallel plate capacitor? Some channels they do hype it like that, paper leak, but it is not, obviously it will be not leaking like right that. Okay, if the paper is leaked, they will change the paper, so don't worry. If someone says paper is leaked, yes, questions can be predictable, so based on that, experienced teacher says that paper is leaked, but actually it is not leaked. Okay, so that is very stupid gimmick some people use. What is the total charge on the parallel plate capacitor in this case? Sufyan, you can trust me or not, that is up to you, but yes, if you study from here, definitely it will help you. That much I can say. Okay, that much I can say. And you can ask the students, those who got help in my midterm paper as well as FA2 papers. Killer Gaming is saying option C. So if you see that, what is the question? Total charge. Total charge. What is total charge? Total charge is, so charge of a capacitor, if the question is charge of a capacitor, then it would be plus Q. Charge of the capacitor plus Q. Okay, total charge of the capacitor is Q minus Q, that is 0. Total charge of any capacitor is always 0. Total charge of a capacitor is always 0. If the question is only the charge, total word is missing, be careful. If the total word is missing, it will be Q. If the question has total in it, that means plus and minus both has to be included. Total charge of a capacitor is always 0, always 0. Okay, if it is only the charge, then it is Q. So when we say that charge of a capacitor, if that's why I ask you to read the NCERT line by line. NCERT has mentioned that in their textbook that total charge is 0, but when we say charge of a capacitor, we generally take the positive charge. Electric field is not 0, but total charge is 0. The capacitance of a capacitor is 6 into 10 to the power of minus 6 farad. It is connected to 200 volt cell. The energy released on discharging it fully will be. So how much energy it will release? So basically, if you want to get the energy released, first of all you have to have the total energy stored. Wow, how much energy is stored? Energy stored is given by half CV square. Okay, capacitance is given, voltage is given. So when you fuse this capacitor, this much exact amount of energy you will get back. So you have to just put the value. This is from one of your previous year paper, 2024 I think, and V square is 200 whole square. Okay, so now cancel 3 into 10 to the power of minus 6 into 4 into 10 to the power of 4. So you get 12 into 10 to the power of minus 2 or 0.12 joules. So the correct answer is 0.12 joules. Option A. How many of you answered A? No one. No question came from the question bank in today's paper. Archana, Bora. See, that's what I was telling you a lot of time, that question bank has a lot of questions. Okay, and in PU board only 10% of that comes in your exam. So 10% of those questions you have to study. So if you have studied entire question bank, very good, you have learned a lot of things. But exact questions do not come from question banks. They will change some questions. Model papers are important, previous year papers are important. Question bank is not that much. If n identical capacitors of and you can practice the question bank for MCQs, by the way, even though the exact MCQs may not come, but the very close MCQs will come from question bank. So that is important. If n identical capacitors of capacitance small c is connected in series, then the equivalent capacitance. So you are connecting in series, capacitance in series. N identical capacitor. What is the equivalent capacitance? Sir, physics was exact copy of question bank. Will physics be the same? It depends. As I say, as someone mentioned that chemistry was not came from question bank, you are saying it is exact copy of question bank. It can vary. Question bank, as I mentioned, question bank has a lot of questions. Okay, 10% questions only comes. Okay, question bank has at least, if I make question papers out of question bank, I can make maybe 100 years of questions without any repetition. Okay, so definitely the only one question paper will come, not 100, right? So you have to be precise and careful what to study, what not to study. I am going to give you the important questions. You can study them. They are the most important, most asked question from history. Okay, so the equivalent capacitance here is C by N. Okay, in case of series combination of parallel capacitor, series capacitor, it is C by N, and for parallel combination, when you connect them in parallel, capacitors get added and it becomes N into C. Okay, when you are N capacitor in parallel, connect them in parallel, then the equivalent capacitance is N into C, whereas in series it is C by N. Okay, remember this. For parallel it gets added NC, for series it will be C by N. Next, if the charge in a capacitor is doubled, then the capacitance is doubled, halved, remains same, quadrupled. Answer this quickly. Alia, you have joined recently. I am going to give you after each chapter. So the format is first MCQ, second important question, third is numerical. So that's how we are going. Okay, so try to answer the MCQ question first. If the charge in a capacitor is doubled, then its capacitance remains same. Okay, now important question, as you are asking what are the important questions, I am reading as per blueprint, but only question bank plus MCQ in question bank. Important derivations are here, so all the derivations you can go and check my fixed question video where all the questions are listed one in single video. Here we are doing chapter wise, so those who have not seen that and want to know, chapter wise, this is electric potential and capacitance chapter. What are all the 2-3 marker question, equipotential surface, definition, shape for different cases, properties, capacitance of parallel plate capacitor, combination of capacitors, expression for energy stored in a capacitor, energy density, potential, so both expression for energy stored in a capacitor as well as expression for energy density of capacitor in terms of electric field. So this is important. Potential energy of a dipole in an external field, polar and non-polar molecules, difference between polar and non-polar, the expression for electric potential at a point due to a point source charge, electric potential due to a dipole. This one you can skip if you have not studied. If you have not studied, you can skip this question. Otherwise, this one is the most important question. Again, from this chapter last year there was a derivation, so I am expecting a derivation will come from the previous chapter and a numerical question will come from this chapter. So you have to practice the numerical based on potential as well. Calculate the potential at a point P due to a charge of 400 nanocoulomb located 9 centimeter away. Harsh, what happened? Game over. Why you are saying game over? What happened to you, Harsha? Harsha R. Calculate the potential at a point P due to a charge of 400 nanocoulomb located 9 centimeter away. So this is a 9 centimeter away and charge is 400 nanocoulomb. Okay. Now, so what you have to do? You have to calculate the potential. Potential, what is the formula for potential? Potential formula is very simple, KQ by R. Okay. So K is 9 into 10 to the power of 9. Q is 400 nanocoulomb. And R is 9 centimeter, but whenever there is a centimeter, there is a 10 to the power of minus 2. Best friend of centimeter is 10 to the power of minus 2. So 10 to the power of 9, 10 to the power minus 9 cancels. This 9 cancels, and we get 400 into 10 to the power of plus 2. This one goes up, becomes plus, or we get 4 into 10 to the power of 4 volt. Okay, so this is the unit of potential. So we have calculated the potential. Next part, it says that obtain the work done in moving a charge of 2 nanocoulomb from infinity to the point P. Does the answer depends on the path along with the charge is moved. So here you have a charge at infinity and of 2 nanocoulomb. You want to bring it over here. You want to calculate the work done. So what is the formula for work done? Formula for work done is Q into V. Simply Q into V. Q is here 2 nanocoulomb, so 2 into 10 to the power of minus 9, and potential we have calculated 4 into 10 to the power of 4. And what is the unit? Unit of work done is joules, so you have to write joules. J. 2 into 4 is 8. 8 into 10 to the power of minus 5 joules. Okay, so this is the work done. It's very simple. Easy question. From potential we can expect easy questions, and this work done is independent of the path taken. This work done does not depend on the path, so you have to write a single line for the last portion as well, because if you don't write that, then you will be losing 1 mark. So be careful about numerical questions. Sometimes we solve the numerical, but we forget to answer some small portions. So do remember that. 3 capacitors of capacitances 2 microfarad, 3 microfarad, 6 microfarad are connected in series. Determine the effective capacitance of the combination. How to calculate the effective capacitance? So in series we know that 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3. Okay, or 1 by 2 microfarad. We are not converting it into farad because it is not necessary over here. We will do it if required in the next step. So it will be 6, 3 2s are 6 plus 3 2s are 6 plus 6 1s are 6. So we get 6 by 6, that is 1. So C equivalent is also 1 microfarad. Because everything is in microfarad, the equivalent capacitance will also be in microfarad. Find the potential difference across 6 microfarad capacitor if the combination is connected to a 60 volt supply. Now that same thing is now connected across a 60 volt battery. Okay, and they ask you what will be the potential drop across this one. So for that, first we will be using the equivalent circuit and find the charge, because in series combination the charge remains same. So we will find the charge from the C equivalent. 60 volt, this is 1 microfarad. So what is the charge in this case? Charge can be calculated Q equals to C into V, and in this case C equivalent. So charge will be C equivalent is 1 microfarad. Microfarad means 10 to the power of minus 6, and voltage is 60. So the charge is 60 into 10 to the power of minus 6 coulomb. Now we will use this charge to calculate the voltage across C3. Same charge is passing across all the capacitors. So from there we can say that Q is equal to C3 into V3. V3 we are trying to find. So V3 will be Q by C3. Q is 60 into 10 to the power of minus 6, and 6 microfarad is the capacitance. So 6 into 10 to the power of minus 6. Minus 6 cancels. So we get 10 volts. So 10 volts is the voltage across the third capacitor. So correct answer is 1 microfarad and 10 volts. Mostly fail chemistry. Sudha Bhumika is saying chemistry, which question bank? KCET warrior, semi please. So Sudha Bhumika, I can tell you that there are many districts and all districts have separate paper setters. So even in some cases you might get questions from the question bank, in some cases you may not get questions from the question bank. So it does not matter. Okay, so you might get questions from question bank and you might not get the questions from question bank. Okay, so it is basically based on which district you are appearing, who is setting the paper. The paper setter decides which question is going to feature in your question paper. Okay, so if it does not make any sense that if chemistry questions are out of question bank, physics questions will also be out of question bank. No. Similarly, if chemistry questions are directly from question bank, physics question will also be from question bank. Maybe not. Okay, but yes, question bank is a good way to prepare. Okay, the exact questions may not come. In a parallel plate capacitor with air between the plates, each plate has an area of 12 into 10 to the power of minus 3 meters square. And I see that most of you are not listening to my lecture. There you are most discussing in the chat that what is the question. Your chemistry paper is over, so don't forget about it. Your physics paper is next. So focus on that. What is next? Don't linger on your chemistry preparation. In a parallel plate capacitor with air between the plates, each plate has an area of 12 into 10 to the power of minus 3 meters square, and the distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. Take epsilon equals to 9 into 10 to the power of minus 12 SI units. Okay, so first of all, what is the formula? We know that capacitance of a capacitor with air between the plates is given by A epsilon naught by D. Okay, what is A? A here is 12 into 10 to the power of minus 3. And epsilon naught is 9 into 10 to the power of minus 12. What is the distance between the plate? Distance between the plate is 3 millimeter. Millimeter means 10 to the power of minus 3. This cancels, 3 cancels, and you get 36 into 10 to the power of minus 12 farad or 36 picofarad. Now this is not a full 5-mark question, that is mostly a 3-marker short answer question. Okay, 36 pf is the answer. If they add one more part with this, then it will become a 5-marker question. So they will give you the capacitor is connected across certain voltage supply, what will be the charge passing through that capacitor. Okay, so that will be a full 5-marker question. Now next is electric current, another very important chapter. Okay, from this chapter again you are going to get a derivation as well as a numerical question. So first answer the MCQs. So you don't speculate. If he says game over, means maybe he has scored 100 out of 100 also. So game over for chemistry because I have scored 100. Okay, I don't have to watch any more videos. Or he has already secured 100 marks in physics as well. The value of internal resistance of an ideal cell is, so what is the value of internal resistance of an ideal cell? That is 0. Okay, the value of internal resistance of an ideal cell is 0. Next, when current flows through a conductor, its temperature increases, decreases, remains same, may increase or decrease. Okay, so when current flows through a conductor, its temperature always increases. Current passing through a conductor, temperature increases. Next, SI unit of current density. SI unit of current density is ampere per meter square. SI unit of current 0. Ultimate evil is saying 0. What is 0? What is 0? SI unit of current density is ampere per meter square. The magnitude of drift velocity per unit electric field. The magnitude of drift velocity per unit electric field. Drift velocity per unit electric field is called mobility of the conductor. Okay, this is called mobility of the conductor. So correct answer is mobility. Okay. Which of the following characteristics of electron determines the current in a conductor? Thermal velocity alone, drift velocity alone, both thermal and drift velocity, none of the above. Ideal resistance is 0. Yes, okay, ultimate evil, sorry. You should answer the option. Answer the option, that is easier for me to understand, right? If you just answer 0, I thought there are some discussing something, right? Dhuba is dancing. I think he has very good score in chemistry. Ultimate evil is saying C. No, not C. Current flowing through a conductor is given by NEAVD. There is no thermal velocity component. Thermal velocities are random, and random motions always gives you average 0. Okay, so current depends only on drift velocity. It does not depend on thermal velocity. Thermal velocities are random motion, so they will always cancel and they will give you 0 value. So if you mark both thermal and drift, then you will get 0 as marks, right? Now your marks will be 0 if you answer this. Okay, so remember this, current depends only on drift velocity, not on thermal velocity. Next, what are all the important questions that might come? Drift velocity, mobility, relaxation time, based on this quantities definition, their interrelation and the interderivations as well. Limitations of Ohm's law, very important. This is very, very important. Difference between current and current density. Okay, resistance and resistivity based questions are also very, very important from this chapter. Now, other than that, 5-mark derivation. What 5-mark derivation you are going to get? Cells in series and parallel. Derive the expression for equivalent EMF for cells in series or cells in parallel. Cells in series is very easy. Cells in parallel is slightly difficult, not so easy. Okay, Wheatstone bridge, most asked question. Again, year after year it came, so it might come in your upcoming pre-board exam as well. And 5-marker numerical is also going to come from this chapter. So let's solve some numerical questions. In the following network, find the current I1 and I2. This question came one of the last year's pre-board exam, so that's why I'm using it. As you can see, some of the students tried to solve it. Now here we have two cells, one is E1, another one is E2. Okay, there is one resistance 4 ohm over here and another resistance 2 ohm over here, no resistance in the lower portion. Okay, they ask you to find the current I1 and I2. Now remember, if a current is passing through a cell, the same current has to come back. Okay, now through this 4 ohm resistor, how much current is being passed? I2 from this side and I1 from this side. Okay, so they are getting added at this branch. Okay, so I1 plus I2 is the current which is passing through the 4 ohm resistor. Now we will simply apply Kirchhoff's voltage law, or Kirchhoff's loop rule. So first we will take this loop, BA DCB, BA DCB. Okay, the top loop. Okay, BA DCB. Okay, from this loop, if we apply Kirchhoff's voltage law, we will see that what is the current through first resistor that we are encountering is this one. Current through this is I1 plus I2, resistance is 4. So 4 I1 plus I2. Next is what? Now we are passing through this R1. So if the current through this is I1, then the current through this will also be I1. Okay, so current through this one will be I1, so 2 into I1, and that is equals to the voltage given here, 12 volt. Okay, now simplify this, 4 plus 2, 6 I1 plus 4 I2 equals to 12. Now you can divide everything by 2, so you get 3 I1 plus 2 I2 equals to 6. This is equation number 1. Now we will take the loop AE FDA. AE FDA. We will take the below loop. This loop is also a closed loop. Now here the current is passing in this direction, so we will take this direction as positive. So what is this? R is 4 into I1 plus I2, and that is equals to the same voltage, 6. There is no other resistance, so simply just do it. So we get 2 I1 plus 2 I2 equals to 3. We divided by 2. Now we have to eliminate I1 and I2 and find the respective values. So how to do that? We will simply subtract equation 1 and equation 2. Okay, so if you subtract 2 from 1 like this, we get 3 I1 plus 2 I2 equals to 6. 2 I1 plus 2 I2 equals to 3. Subtract minus, minus, minus. So this cancels, we get I1 equals to 3. So I1 equals to 3 is calculated. Now we have to calculate I2. So now put this I1 value in any one of these equations to calculate I2. So 3 into 3 plus 2 I2, we are using this equation, okay, equals to 6, or 2 I2 equals to 6 minus 9, that is minus 3. So I2 equals to minus 3 by 2. Don't afraid of negative sign. Negative sign indicates the current is not flowing in this direction but in the opposite direction. Current will be in the opposite direction, not in the same direction. Okay, that is the meaning of negative value. Okay, so correct answer is I1 is 3 ampere and I2 is minus 3 by 2 ampere. Okay, let's move on. 3 resistors, 2 ohm, 3 ohm and 6 ohm. Anyone answer me please. Srinivas is saying, hey, tomorrow's exam I am not study here. IPL, if you watch IPL 2025, that happened last year. YouTube Orange is live. Sir, please explain Wheatstone Bridge. Okay, I will do it. Just wait for a second. I am new to this channel, so anyone tell me what is your question? Srinivas. What is your question? Please ask it properly. I just see that you have mentioned I am new to this channel. So anyone tell me what I should tell you. You can ask me. Wheatstone Bridge, due to orange, I will come with the explanation for Wheatstone Bridge very soon. Don't worry. Okay, so 3 resistors, 2 ohm, 3 ohm, 6 ohm are combined in parallel. What is the total resistance of the, by the way, those who are wondering that I have not studied, just remember, tomorrow morning I am going to do a very short revision video. Okay, there I am going to discuss all the important questions in a brief. Okay, that may not be sufficient for you to score 60 plus, but that will be sufficient for you if you are someone who has not studied anything, and if you are someone who just want to get know about most important questions like Wheatstone Bridge and some important derivations, some important 2-3 marker questions. You should check that video, and I can guarantee that if you watch that video, if you are someone who has not studied at all, you will get the passing marks. And if you are someone who has studied and just want to revise it, that will guarantee you will score more than 60. Okay, it will be released tomorrow morning 5 AM. You can check any time after that. 5 AM tomorrow morning. Fixed question, yes, Varalakshmi, that will come. Dharmax, what time, sir? 5 AM tomorrow morning. 5 AM tomorrow morning. 5 AM, that is a under 30 minutes review, under 30 minutes revision. Okay, so just spend 30 minutes before exam, and all important questions, those who are just saying that I have not studied at all, or someone is saying that I just need some important question practice, that is sufficient. So it can make you score more than 30 marks. Okay, if you are starting from 0, if you are already have 30 marks, then you might score 60 plus. Okay, so it depends on which level you are. If you are already at 50 plus, it might take you to 70 plus as well, 70 marks as well. Okay, out. So today's video and that 30 marks video, 30 minutes video is very essential. So don't miss that video. Okay, that is very, very important for all of you. Only 30 minutes. JE aspirant, sir, I am scared of KCET. KCET is a long back. We have 4 months still left. I have made one video on the strategy. You can go check that out. Okay, so that will be perfect starting point. 3 resistors, 2 ohm, 3 ohm, 6 ohm are combined in parallel. What is the total resistance of the combination? Parallel combination of resistance, 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so that will be 1 by 2 plus 1 by 3 plus 1 by 6. So that is 3 plus 2 plus 1 by 6, that is 6 by 6, that is 1, and 1 by R equivalent. Do not write ohm over here because it is 1 by R equivalent. So R equivalent is 1 by 1. So fortunately that is 1 ohm. So R equivalent is 1 ohm. If this combination is connected to a battery of 2 volt and negligible internal resistance, determine the current through each resistor and total current drawn from the battery. So now this combination of resistors are connected across a battery of 2 volt. You have to find the current through each branch. So this is I1, I2, I3. So this is say 2, 3, 6. Okay, so how to calculate that? First of all, you have to know that in case of parallel combination, the voltage remains constant. So each of the resistances, they are actually individually connected to this 2 volt battery. So how to do that? 6 resistance 2 volt is the, so let's start with I1. Okay, 2 into I1 equals to 2 volt, that is I1 equals to 1 ampere. Similarly, 3 into I2 equals to 2, so I2 equals to 2 by 3 ampere, and 6 into I3, again that will be equals to 2, so I3 equals to 2 by 6, that is 1 upon 3. So I3 equals to 1 upon 3. So these are the 3 important currents. So once you have calculated the currents, total current through the battery will be I total equals to I1 plus I2 plus I3. That is, this is the total current, I total, right? So this will be equals to 1 plus 2 by 3 plus 1 by 3, that is 2 ampere. Okay, so the current through the battery is 2 ampere, equivalent resistance is 1 ohm. Okay, and individual currents are 1 ampere, 2 by 3 and 1 by 3 ampere. Easy question. For copper, the number density of free electron is 4.5 into 10 to the power 28 meter cube per meter cube. The resistivity is 2 into 10 to the power of 8 ohm meter. Calculate the conductivity of copper and relaxation time of free electrons in copper. Take the mass of electron 9 into 10 to the power minus 31 kg, E equals to 1.6 into 10 to the power minus 19 coulomb. Okay, so first stage is to calculate the conductivity. What is conductivity? Conductivity is given by sigma. Sigma equals to N E square. Oh, sorry. N E square tau by M is conductivity. Okay, so this is the formula for conductivity, but we are not going to use this formula for conductivity. We will use this formula to calculate relaxation time. But how to calculate conductivity? Here resistivity is given, so conductivity will be simply 1 upon resistivity. Okay, conductivity is simply 1 upon resistivity. You cannot calculate some equation where 2 unknowns are there. Okay. But fortunately resistivity is given, so we can calculate the conductivity from resistivity, 2 into 10 to the power of minus 8. Okay, so from here we can say that this will be 10 to the power of 8 by 2 or 5 into 10 to the power of 7. 5 into 10 to the power of 7 is the conductivity. Now we have to calculate the relaxation time. Relaxation time is m sigma divided by N E square. So now put the value. M is given here 9 into 10 to the power of minus 31. Sigma is 5 into 10 to the power of 7. Now number density given here 4.5 into 10 to the power of 28, and charge of an electron is 1.6 into 10 to the power of minus 19 whole square. So now you have to simplify some of them. 2, okay, 2 into 5 is 10, 10 into 10 to the power of minus 24, this 2, okay, divided by 10 to the power of 28 into 2.56 into 10 to the power of minus 38. So that will give you approximately value of 0.4, approximately 0.4 into 10 to the power of minus 13 seconds, or 4 into 10 to the power of minus 14 second. Okay, so this is the approximate value of the tau, and relaxation time we have already calculated, 5 into 10 to the power of 7 or 0.5 into 10 to the power of 8, both are same. Okay, so this is can be given as per ohm per meter. Okay, the unit of resistivity is ohm meter, so unit of conductivity will be per ohm per meter. Okay, and unit of relaxation time, right, so its unit will be in seconds. Now someone asked me to explain Wheatstone bridge. So Wheatstone bridge, what you have to do? Very simple. So there is a shortcut way, there is a long way. Most of the teachers teach the long way, I teach in the shortcut way. Okay, so I have already discussed it in tomorrow's morning lecture as promised, but again someone asked me, so how can I refuse? So the current through this, say I1, current through this, say IG, current through this, say I2, current through this, say I3, and through this say I4. Okay. Sir, I studied first 4 chapters and last chapter. Dharmax is saying if you have studied first 4 chapter and last chapter, you can expect 35 to 40 marks, not more than that. Sir, in numericals, first question is of the electrical charges and fields or electrical potential. That is not guaranteed, Juvraj. It can be either of them. Okay, first numerical can be either of them. One, so basically first 2 chapters are combo chapters. Okay, so you do not consider them as individual chapters, they are actually combo chapters. From one of the chapter there will be a derivation, other chapter there will be a numerical. Now which one will be what, that varies from year to year, examiner to examiner, paper setter to paper setter. Okay, some districts you might see that first chapter from where you are getting the derivation, second chapter we are getting the numericals. In some district you might see that first chapter you are getting the numericals, second chapter you are getting the derivations. Okay, so that depends on district to district and paper setter to paper setter. Dharmax is saying all MCQs went. If we study, how much we will get average? Varalakshmi, please say how many chapters I should study only derivation. So only derivation you should study first 2 chapters. Okay, current, electricity, moving charges and magnetism, and the last chapter, okay, the semiconductor. So if you study the all derivation from this chapter, that is sufficient. And other than that, there is a derivation, possible derivation will come from wave optics, and that's it. Okay, first 2 chapters, derivations and numericals both will come, one of them, one each. Now which one will be what, that is not clear. Okay, second chapter, first, second chapter, third chapter is current, electricity. From there you are going to get a numerical as well as a derivation. Okay, and the last 4th chapter also you are going to get a derivation for sure. 4th chapter we are starting. Okay, 4th chapter also you are going to get a derivation. Then last chapter, semiconductor, also you are going to get a derivation. Okay, now let's see. So as I mentioned, Wheatstone bridge. So I1, I2, I3, I4. Now what is the condition for balanced? Condition for balancing is the galvanometer current is 0. That is the condition for balance. So Ig equals to 0. Now if Ig equals to 0, what we can say? This is the junction, right? What are current incoming? I1. What are the current outgoing? Ig and I2. Now Ig is 0. That means from there we can say I1 must be equals to I2. Similarly, from this junction we can say I3 equals to I4. Okay, because Ig is 0. Balance condition means Ig is 0. Now you take 2 loops, A, B, C, D. Okay, you take A, B, D, A, this loop first. So A, B, D, A loop, apply Kirchhoff's voltage law. I1 into, so this is P, Q, R, S. P into I1 plus 0. We are going in this direction. Okay, we are going in this direction. So I1 into P in plus 0, and then we are going in this direction, and we are getting I3 into R, but in the opposite direction. So minus I3 into R, that is equals to 0. No battery is connected in this junction, so it will be equals to 0. So Pi1 equals to I3R, or P by R equals to I3 by I1. Similarly, now you don't need to do anything, you just need to write similarly. Okay, Q by S equals to I4 by I2. Remember this order, Q by S equals to I4 by I2. Okay, now I4, what is I4? I4 is I3. And what is I2? I2 is I1. Now if you see that both sides of the 2 equations are same, so we can say that P by R equals to Q by S, or P by Q equals to R by S. Okay, so this is the correct answer. This is the correct answer. and very simple, easy derivation. Don't be afraid, just practice it 2-3 times, you should be good. Ray optics and wave optics. Ray optics, we are expecting a numerical question, not any derivation, okay, but some district they might give in the opposite order as well. So ray optics derivation, wave optics numericals, okay. So they are also as a pair of chapters, but what I can expect from my experience, I can say that most of you will get numerical question from ray optics and theoretical question from wave optics, okay. Some of you will get the reverse as well, but 90% of the students will get ray optics as their numerical question and wave optics for theory. But as I mentioned, if you study the chapters I mentioned, first 4 chapter and the last chapter, then your derivations will be sorted. You don't need to practice any derivation from anywhere else. Don't get tensed, Vasu Gowda. Don't get tense. If you get tensed, you will start forgetting, and if you start forgetting, you will lose marks, okay. So don't be tensed. Try to answer the questions along with me. Current and almost we are done with the most of the numericals, okay. If you want, I will solve some more numericals from ray optics, otherwise I will skip and I will move on with the flow. A current I flows along the length of an infinitely long straight thin walled pipe. Then the magnetic field at all points inside the pipe is same but not zero. At any point inside the pipe is zero only on the axis of the pipe, is different at different points inside the pipe. So we have a thin walled pipe. Pipe means inside is hollow, right? Pipe means there is nothing inside. So they are saying what is the magnetic field inside. For that, what we have to consider? We have to construct an Amperian loop. If we construct an Amperian loop, we know that B dot dl equals to mu naught I. Now all the current actually flowing along the surface because it's a pipe. So inside the pipe current is equals to 0. Okay, so inside the pipe current is equals to 0. So B dot dl must be 0. Now dl is along the shape, so dl cannot be 0. So only thing that can be 0 is B equals to 0. So all points inside the pipe will be 0. Okay, 0 at any point inside the pipe. 0 at any point inside the pipe. This is coming from the Ampere's circuital law. Sneha, I am speaking loud enough. Just check your speaker volume. Okay, study for your success. We don't want to skip anything. I will continue. Don't worry. How was it came paper? How much we will get if we study this question? No, only one question if you study, I am not sure how much you will get, but if you study all these questions, you are going to get your MCQs correct, you are going to get your numerical correct. That means 15 plus 10, 25 marks is guaranteed, and if you study the questions that I have mentioned, then you can score another 45 marks. So total up to 70 marks you can score if you study everything that I am discussing in this lecture. Okay, so 70 marks is at stake, 70 out of 70. Okay, so don't skip. When a magnetic compass, and that is my guarantee by the way, if you study everything you will score 70 out of 70. When a magnetic compass needle is carried nearby to straight wire carrying current, then the straight wire causes a noticeable deflection in the compass needle. So when the straight wire carrying current, if you place a magnetic needle near the straight wire, okay, so you would see a deflection in the wire, in the needle. The alignment of the needle is tangential to all imaginary circle with straight wire as its center. So if you try to find the alignment, okay, if you try to find the alignment, it will be, you draw a circle and the alignment will be along, at all point it will be along the tangent of the circle. Okay. Now why it is so? Because magnetic field lines due to a straight current carrying wire is circular in nature. How to do that? To find that, point your fingers towards the current and then curl your fingers. Then you will find the magnetic field direction. So they are basically circular in nature. Okay, so both 1 and 2 are correct. Both 1 and 2 are correct. Both of them are correct. If a current I is flowing in a straight wire parallel to positive x-axis, the magnetic field is there along the positive y-axis, then the wire experiences a force in negative x direction, the wire experiences a force in the positive y direction, the wire experiences a force in the negative z direction, the wire experiences a force in the positive z direction. So first of all, remember that current is in positive x-axis, magnetic field is positive y-axis, the force will be in the z direction, mutually perpendicular. Whether it is positive or negative, that we have to figure it out. Okay, so how to do that? You have to point your fingers, direction of current, magnetic field, then the thumb will give you the direction of force. Okay, so that is Fleming's left hand rule. Okay, so Fleming's left hand rule states that when you are allowing a current passing through a wire, okay, and the other thumb is pointing the direction of magnetic field, then the thumb will give you the direction of force acting on it, and from there we can say that x cross y equals to z, so it will be positive z direction. It will be positive z direction. If both are positive, then it will be z, positive z. If one is positive, one is negative, then it will be negative. Ramesh Nayak, I already given a video. You have not watched it. All important questions in one video. It is, I already given it. Okay, it is already out. Please go and check that out. Sir, if you study last marathon of preparatory physics is enough. Last marathon, yes, Chida, that means you are talking about the all important questions. Yes, that is enough, but there you have to check the MCQs separately as well. MCQs as discussed by Aditi ma'am, separate 100 video along with my marathon video. That is sufficient. If you watch those, you can score 60 plus easily. Okay. Today I am just going some revisions, also some separate kind of numerical questions I am discussing. A strong magnetic field. So if you have seen that video, then you can watch this video as well, because all important questions and numerical questions also I am discussing. A strong magnetic field is applied on a stationary electron, then the electron remains stationary. Stationary electron does not move, okay, in the application of magnetic field. It will move in the application of electric field, but stationary magnetic electron means it does not move. That means velocity is 0. So velocity v0 means q, v cross b is 0. So the Lorentz force of magnetic field is q v cross b. So v is 0 means the force will be also 0. The radius of circle described by a charged particle moving perpendicular to a uniform magnetic field depends on its mass, its velocity, both mass and velocity, neither mass nor velocity. So the radius of the circle. So how to do that? Force is q vb and it is given by mv square by r. So v, one of the v's gets cancelled, r equals to mv by qb. Okay, so radius of the circle when magnetic field and velocity are mutually perpendicular. So as you can see, it depends on the mass, it depends on velocity. Okay, so both mass and velocity on which the radius depends. Not only that, it also depends on the charge as well as magnetic field. Now what are all the questions going to come? Definition of Lorentz force, very important. Angular frequency, radius of revolution. Radius of revolution is this derivation. Okay, angular frequency can also be derived from this same expression. Only thing you have to put is that v is equal to r omega. If you substitute in this equation, you can also calculate omega, that is angular frequency. Force on a current carrying wire, Biot-Savart's law, Ampere circuital law, galvanometer to ammeter voltmeter conversion. Very, very important one of the conversion is going to come in your pre-board. Magnetic field at a point on the axis of a circular current loop, very important. Force between two parallel current carrying wire is also very, very important. These two are the must practice derivations. Okay, magnetism and matter, easy question, easy chapter, right? Someone is typing long. Nagaraj is saying 4B. Okay, Nagaraj, sorry I missed your options. Some ultimate evil also I missed your question. Sir, yesterday chemistry ma'am did same series live session, but today questions were not similar, completely different. So we are not sure about physics questions coming tomorrow. Sinchan. So this is a so if you watch this video, okay, if you have watched yesterday's chemistry ma'am's video, you did not get any question common, but there are 99 other students, they get questions common as well. Okay, so do not judge by book by its cover only. Okay, so if you may not get the questions common, but I can assure you that if you watch today's session, definitely you are going to get questions common. Okay, and many students will get questions common. Some of you may be unlucky, some of you may not get that questions common, but most of you are going to get those questions common. Okay, someone was posting very long comment, I missed those comments. Sir, explain 6th question in 2 marks, Nagaraj is saying. Okay, galvanometer to ammeter and voltmeter. The thing is, first of all, how can you convert galvanometer to ammeter? Galvanometer to ammeter is when you convert, add a galvanometer and add a small shunt resistance across it. Why so? We want to reduce the effective you want to reduce the overall resistance. You want to reduce the overall resistance of the galvanometer. Now, how can you reduce some resistance? To reduce resistance, you have to use parallel combination. Now, why you want to reduce the resistance? Because ammeter in a circuit is used in series. Okay, so series. So if you want to measure the current, you have to connect it in series so that you can measure the exact amount of current passing in the circuit. Now, if ammeter itself has very high resistance, then it will disbalance the circuit. When you are measuring, you will get some current, but when you have removed the ammeter and try to operate without ammeter, you will get completely different current and your circuit may get burned. So ideally an ammeter should have zero resistance, but in practicality that is not possible. So in practicality what we try to achieve is that as low as possible, and for that we apply a shunt resistance along the parallel of the galvanometer. Okay, now if say current that is passing in the galvanometer is given by current in the circuit which is passing by I, only a portion of that current will pass through the galvanometer, remaining current will pass through the shunt. Okay, so what is the current that you are measuring? The current that you are measuring is given by G plus S divided by S into Ig. Now Ig is the, if you know the maximum galvanometer current, then you can calculate the actual current that is passing through the galvanometer. Actual current that is shown in the meter. Okay, that's how the galvanometer is calibrated. Okay, so first thing you have to mention that because ammeters are used in a series combination, okay, we want to have a very low resistance of the galvanometer, and because of that we want to apply a shunt resistance in parallel. Shunt is basically a low value resistance. Okay, and the current in the circuit can be measured as this formula. Now second part is galvanometer to voltmeter. This one is galvanometer to ammeter. Galvanometer to voltmeter, what you have to do? You have a galvanometer, okay, and voltmeter, how do we connect voltmeter in the circuit? Voltmeter in a circuit is connected in parallel. Okay, voltmeter is used to measure voltage, so we use it across a resistance, so it is connected in parallel. Now parallel resistance, if they are very low value, then again it will disbalance the circuit and it will give you wrong reading. So ideal voltmeter should have a infinite resistance. Ideal voltmeter should have an infinite resistance, but again ideal voltmeter is not possible, so we try to keep a voltmeter of resistance as high as possible. How can we increase resistance? To increase resistance we have to add a external resistance in series with the galvanometer. Okay, sir, today's exam wasn't exactly what we learned yesterday's in chemistry, only a few questions appeared. Tejashwani, as I told you, Expression for voltmeter also I am giving, just a second. Tejashwini, it can happen as I mentioned, okay, don't worry about it. Chemistry, some questions may be, some district questions may not be common, but in today's Saini ma'am's live video, there are many students came and they said I got exact the same questions that you mentioned, okay. It varies to district. Some district it may be little difficult, little different questions I have come, but if you follow my lecture, all the questions that I am giving you, if you study those questions, you are definitely going to get full marks, most of the marks, okay. Not all the questions you are going to get common, as I mentioned, okay. There will be some questions which will be new, some questions which are uncommon, but if you study all the questions I am giving you, I can guarantee that you will at least be able to answer the mandatory questions, okay. 5 2 marker, 5 3 marker, 3 derivations, you will be able to answer them. Extra questions, not my guarantee, but 5, and you should study everything, okay. You should study everything, then you should definitely be able to answer 5 2 marker, 5 3 marker and 3 derivations. Numerical questions I am discussing in this lecture. You may have missed the previous portions. We have already discussed 3 very important chapters numericals, so do check that out. And also in my long video that I have done long before marathon, there I also have discussed some numericals. Do check that out as well, okay. So now suppose the current in the galvanometer is Ig. Now galvanometer is not used to measure current. What it is being used for? It is used to measure voltage, okay. So the voltage that is measured is given by G plus R into Ig. So in every case, ammeter is used to measure current, so we are finding the current, and voltmeter is used to find the voltage, so voltage is given by G plus R into Ig. So this is the galvanometer current. Each cases galvanometer current is generally fixed. So when you are measuring the maximum value of voltage, so this is how the calibration is done. Maximum galvanometer current is fixed value. If more than that value goes through the galvanometer will be burned, okay. So that's why we only use the maximum limit of the Ig. So this is the maximum voltage it can measure, this is the maximum current it can measure, okay. And the expression is very simple, G plus R into Ig, okay. Okay, Nagaraj. Now Manvita is saying, I think saying 5th question, Ampere circuital law. Ampere circuital law is very easy. B dot dl equals to mu naught I, okay. You just need to write it along with the diagram, current passing and some wordings, okay. The net magnetic closed integral of magnetic field and line element is basically the current enclosed by the closed curve times mu naught, okay. Statement is very simple. This is very easy question. All the questions are very easy. Galvanometer to ammeter may be slightly tricky. Angular frequency and radius of revolution I have already shown you, okay. So R is equal to mu by R. So this is the Lorentz force, this is centripetal force, they must be equal. From there you have to calculate radius, and if you put V is equal to R omega from rotational motion, then you can calculate the omega also. So R equals to M into R omega by QB. So from here R cancels, so we have 1, so we get QB by M equals to omega, okay. So this is the expression for angular frequency. These are the important questions from this chapter. Now let's move on. Magnetism and matter. The expression for motional EMF is BVL sin theta, BVL cos theta, BL by V. Okay, so what is the expression for motional EMF? Expression for motional EMF is BVL, okay. Expression for motional EMF is BVL. To include EMF in a coil, the magnetic flux linking must remain constant, must increase, must decrease, both B and C. So induce EMF in a coil, the magnetic flux linking must remain constant. Is it? Must increase or must decrease? Which was it? To induce EMF in a coil, okay, we know that it is d phi by dt. So does not matter, they have not mentioned the sign of the induced voltage, so it can go up, so flux can go up, flux can go down with time. Okay, so flux linked can increase or decrease with time, then only we will get an induced EMF. So both B and C, both B and C. When a magnet is moved with its north pole towards a closed coil, the nearer end of the coil acts as north pole, south pole. No magnetic field is induced, both north and south pole are induced. So we have a closed coil and you are bringing a north pole towards the coil. So when you are bringing a north pole towards the coil, okay, then the coil will have a south pole near to the magnet's end, so that it will induce a north pole near to the end of the coil, so that, and current will be flown accordingly, so that they repel each other and it will stop the approach. Okay, so it is basically north pole. So even if you are bringing a north pole, the coil will produce a north pole. Next, the magnetic flux linked with the coil varies as phi equals to 2t square plus 2t. What is the magnitude of induced EMF at t equals to 0.05 second? So phi equals to 2t square plus 2t. Okay, so d phi by dt equals to 4t plus 2. I think the options are wrong. Okay, so what is the magnitude of induced EMF? Magnitude of induced EMF is d phi by dt at t equals to 0.5. So 4 into 0.5 plus 2, that is 2 plus 2, that is 4 volt. So the correct answer is 4 volt. Okay, so induced EMF is 4 volt in this case. Next question, the magnetic flux through a surface of area A vector placed in an uniform magnetic field B is defined as B dot A dot B cross A cross B, B by V. Sir, time is too less. Shashi Kundaragi, actually I am trying to finish the lecture is slightly quickly, that's why I am going little faster, nothing else, because I promised it I will try to complete it little quickly. So don't worry, you can start posting the answers in the comment. I will check and I will answer it. Okay, don't worry about the time that I am giving. Okay, Nagaraj is saying 3A, 4, which 4 you have not answered. Okay, 4 obviously 4 is not able to answer. 5th you are saying 5A. Manvite is saying prism derivation. Prism derivation you can skip it. For pre-board you skip that derivation. If you have not studied that, you can skip it. Okay, option A, yes, 5A is correct. Now what are all the important questions? Difference between dia, para, ferro, magnetic materials. One of this is coming every year in your board exam, so I can expect one of these will come in your pre-board exam as well. Properties of magnetic field lines, Gauss's law of magnetism, magnetization and magnetic intensity definitions, magnetic susceptibility and relative permeability. These are all the important questions from this chapter. Next, electromagnetic induction. Let me give you some time. Okay, Shashi, try to answer. The susceptibility of ferromagnetic substance is greater than 1, 0, very greater than 1, less than 1. I think I have okay, these questions are not electromagnetic induction, there is some mistake. So this is magnetism and matter, but the MCQs are from electromagnetic induction, and this is so slightly swapped, sorry for that. This is these questions are from magnetism and matter, but chapter heading is electromagnetic induction. I will try to correct that in the PDF version, and the PDF will be available after the lecture is over. The susceptibility of a ferromagnetic substance is greater than 1, 0, very very greater than 1, less than 1. Manvit, the important questions are shared all the important questions are shared, and we have done a long marathon that is also shared the PDF in the WhatsApp channel. You can go and check that out. Okay, not all the questions I have not covered yet because pre-board we do not have a lot of time to prepare. So all the questions obviously we do not have the time to prepare, and we will be doing those all the questions before your board exams. But most important questions and their answers are discussed in one of the marathon series. You can go and check that out. That link of the WhatsApp channel is given in the description, and the PDF shared, already shared. It will be shared once more after this lecture is over. So it will be available there. Okay. Half-life wave rectifier Haley. Half-life, no. Boy, it is not half-life, it is half-wave rectifier. Okay, half-life you studied in chemistry. Okay, half-life was there in physics, but it is deleted. Now half-life is only there in your chemistry. Okay, so you have confused. Okay, I will discuss. So as I mentioned, check the 5 AM video tomorrow. 5 AM video you can check it up to obviously before your exam. Your exam starts at 10 AM. So 5 AM there will be a video where all the important questions, Wheatstone bridge, galvanometer to ammeter, ammeter to voltmeter, half wave, full wave, everything will be discussed in less than 30 minutes. Do check that out. I request you, Lohit. Sir, from only will come the question. Yes, from the questions that I have shared, from there it will come. Okay. How much can I get, sir? Maya Yadav. Maya Yadav, as much as you want. If you study all the questions, you can get as much as you want. 70 plus. Okay, 70 marks maximum. But you have to study. Okay. So that is up to you. If you are just starting now, if you watch the 30-minute video in the early morning, less than 30 minutes, not even 30 minutes, okay, the total recording time was less than 30 minutes. There will be some cuts made here and there, so it will come out to around 28-27 minutes. Okay, so if you watch that, you will score 30 plus marks. That is my guarantee. The susceptibility of a ferromagnetic substance is ferromagnetic substance. It is very, very greater than 1. Very, very greater than 1. Once. Yes, Ranjana 4700. Hi. Which of the following properties is false for a bar magnet? It does not produce magnetic field. It poles cannot be separated. It points in north-south direction when it's suspended. It's like poles repel, unlike poles attract. Which of the following properties is false? Okay, false. False means wrong. So it does not produce magnetic field. A magnet does not produce magnetic field definitely sounds wrong. So this is the correct answer, right? Yes, Amar Ramma. Okay. Yes, Sakshi, I am doing fast, very fast. Susceptibility of a certain magnetic material is 400. What is the class of the magnetic material? Diamagnetic, paramagnetic, ferromagnetic, non-magnetic. 2A correct. So 2A correct. Third is 400. 400 is very, very greater than 1. That means it's a para. No para. It's a ferromagnetic. Okay. So if the susceptibility is very, very greater than 1, then definitely it's a ferromagnetic. Next, the magnetic field lines inside a bar magnet. So outside a bar magnet, magnetic field lines travel from north to south, and inside the bar magnet it's from south to north. Okay, so inside the bar magnet it is from south pole to north pole. Okay, outside it is north to south, inside it is south to north. When a bar magnet of dipole moment m vector is placed in a uniform magnetic field B, okay, the torque acting on it, the torque, so what is the torque acting on a magnetic dipole? So the torque acting on a magnetic dipole is small m cross B. Small m cross B. It is small m cross B. 5A, yes, yes, very fast. Nagaraja is answering very, very fast. Next, what are our important questions? Faraday's law, Lenz's law, expression for self-inductance, coil magnet experiment, motional EMF. As I mentioned, the chapters got mixed up a little bit, sorry for that. So these are the important questions from this chapter. Next, alternating current. So alternating current, you are only going to get MCQ and numerical question. An ideal step-up transformer decreases current, power, voltage, frequency. Amarama is saying A. Okay, 5A was correct. Now answer this, everyone. An ideal step-up transformer decreases. Step-up transformer means it increases voltage. So voltage increases means current must be decreasing. Okay, so current is being decreased. Okay, yes, not Nagaraj, not 1C. Power remains same. Power is same. Voltage increases. Frequency independent. Frequency you can change it in some other way. Okay, but frequency mostly remains same. Okay, 50 hertz is the standard frequency. Frequency remains same. Voltage increases, power remains same, only current decreases. Okay, remember that ideal transformer have same power. So power input equals to power output. That means power remains same. In series LCR circuit, the L and C are interchanged. The resonance frequency of the circuit increase, decrease, remain same. There will be no resonance. Okay, Amanamma answered correctly, A. And javelin thrower. Javelin thrower throws the javelin perfect. Now answer this. Now throw the javelin on this question. A series LCR circuit, L and C are interchanged. The resonance frequency of the circuit will be increase, decrease, remains the same. There will be no resonance. So if it is an LC circuit and if you interchange them, okay, resonance frequency is given by F naught equals to 1 by 2 pi square root of LC. Okay, so there is no interrelationship whether L is first or C is second. Both cases, even if you interchange L and C, the resonance frequency will remain the same. Yes. Javelin thrower, no, not B, not B. It does not decrease, okay. L and C, even if you change L and C, okay, it will remains the same. Interchange, relative distance does not matter. Next, in a transformer, the windings of the primary and secondary coils are wounded one over another to reduce the energy loss. So here we have, so you missed the javelin now. So one coil is wound over another. Okay, winding means that circular coil. Okay, this is called windings, and wound is not the wound that you get. This wound is not the wound. Okay, so this is because flux leakage. This is because to stop flux leakage. So this is a property of transformer, and this is basically stops flux leakage. So correct answer is flux leakage. Okay, 3C, yes, correct. Not eddy currents, flux leakage. Not eddy currents, not eddy currents, flux leakage. Oh, you have answered eddy current. No, eddy current is not correct. Eddy current is, what is eddy current? If this is the transformer core, you have seen transformer core like this, right, in your diagrams, book diagrams. So when you suppose this is your primary, this is your secondary, okay, now there is a current developed in this core. There is a current developed in this core. This current does not do anything. This is basically waste of power. Why so? So if you see that there is a current, right, and this is a conductor. So current passing through a conductor. So basically it will give rise to heat. So heating effect of current. So basically you will lose some energy because of the Joule's heating I square RT. Okay, because of that you will lose some extra current, and that is because this coil is also a conductor, right? This material is also a conductor, and the flux change through this coil will also affect or also induce a internal current, that is called eddy current. And how to reduce the eddy current? Eddy current is reduced when we construct the transformer. We do not make it a solid block. Instead of making it a solid block, we make it small laminated core. So if you open a transformer, you will see that the transformer is not made of single solid block. Instead, it is made up of very thin layer of metals. And because of the thin layer of metals, the current is reduced significantly, the heating effect is reduced significantly, and that's how we reduce eddy current. So laminated core means this plate is separate from the other plate. This is a separate plate, but entire structure, this coil is wounded over entire structure. Okay, so this is a three-dimensional figure. Okay, so this laminated core prevents of high eddy current. Eddy current you cannot stop, but you can reduce the value, and by reducing the value you can reduce this heating effect. Okay, so that's why transformers are always getting hot, because of the eddy current. And one more application of eddy current is if you have ever went to a airport security or mall security, where the security guard check you using a device, metal detector, sound it makes. Okay, that is basically due to eddy current. So whenever if you have a metal present in your body, okay, when the detector is being passed near your body, okay, there is a eddy current induced in the metal, and that current is being measured by the detecting device, and that's how they detect whether you have metal in your body or not. That is the way. Okay, so eddy current is one of the application there. Anyway, eddy current is not part of the syllabus anymore. It was there, but now it is not there, so you don't need to worry. In the case of alternating voltage applied to a resistor, the current leads the voltage by a phase angle of pi by 2. The current lags behind the voltage by a phase angle of pi by 2. So current and voltage are in same phase. Current and leads the voltage by a phase angle of pi by 4. Pi by 4 is not correct. Either leading or lagging by pi by 2. Same phase is also not. Same phase can be correct because it's a resistor. It can be correct. Okay, let's see. Sir, do you know BVB college? No, I don't. Okay, 4C. Current and voltage remain same. Yes, because it's a resistor, current and voltage remain same. Okay, the current leads the voltage in case of capacitor, and current lags behind the voltage in case of inductor. So this is for capacitor, this is for inductor, this one is for inductor. Okay, next, the input voltage of a pure capacitor is V equals to Vm sin omega t. Then the current in the circuit. So similar question, slightly rotated around. Now answer, what is the current? Current leads or lags? Okay, current leads or lags? Samrudh, where it is? Tell me. 5B. Yes, current is leading. Leading means this is plus. So what is the meaning of leading? So when you write it, the current equation, instead of writing just sin omega t, you have to write omega t plus pi by 2. Current, voltage will become current, and sin omega t will become sin omega t plus pi by 2. So this is the meaning of leading by pi by 2. Pure capacitor leading, this is the inductor where it is lagging. Okay, inductor is lagging. Sin cannot be changing into cos abruptly. Yes, you can change this one to cos omega t. Okay, if it is I equals to Im cos omega t, that could have been correct based on the sign. It can be minus, it can be plus, so that is okay, but definitely you have to remember that you cannot abruptly change the sign to cos. So this is not correct, this is correct. Let's move on. Power loss in transformer. Now generally from this chapter we are not going to expect any 2-3 marker question, but if in case they deviate from the model paper, okay, model blueprint, then you might see 1 or 2 question based on the power loss. Okay, no derivations, but numerical questions will come. numericals will come. Let's see few numericals. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied. Now remember this, usually the chapter I have chosen some questions which are slightly easier for mathematical calculation. Formulas you have to remember, same formulas each and every year there will be a question based on the same formula, same concept, okay, but the answer, final answers will require calculator to solve, remember that, okay. You will not be able to solve them without using calculator. Pi value is 3.14, etc., etc., that is important. So sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit, no L here, only R and C, with R equals to 3 ohm, C equals to 800 microfarad. Calculate impedance of the circuit, the current through the circuit, phase difference between current and voltage. So everything is covered in this one single question. So first of all, how to find the impedance? To find the impedance, first step is to calculate XL and XC. Now L is not here, so only XC is sufficient. What is XC? XC is 1 by 2 pi F into C or omega C. Omega C based questions come in KCET exam. In board exam there will be always 1 by 2 pi FC based question, okay. This 2 pi F can be replaced as omega, that's it. Anyway, so now 1 by 2 pi into F is given here as 50 Hz and capacitance is 800 microfarad. Micro means 10 to the power of minus 6. So now simplify, so you get 15, so 10 to the power of minus 6 goes up, becomes plus 6. In the division we have 2 into 50 is 100 pi into 800. Now what? 1, 2, 3, 4 zeros are here. So what we can say is that 10 to the power of 6 divided by 8 pi into 10 to the power of 4. Right? 1, 2, 3, 4. 8 ones are 8. So now we can cancel some of them. So we get 10 square by 8 pi or 100 divided by 8 pi. And 8 pi will almost be 25. You can use the calculator to calculate. So you will get this as 4 ohm. Remember, XL and XC will have same unit as resistance. That is why it is called capacitive reactance, and it came out to be 4 ohm almost. Okay, so now next step is to calculate the impedance. Normally impedance is given by square root of R square plus XL minus XC whole square. But here as you can see, XL is not there at all, not at all there. So XL will be 0. So minus XC's whole square. What is minus XC's whole square? Minus XC's whole square can be written as only XC square. Okay, remember this is very important. Now you just need to put the values to calculate the impedance. This is part A. R is 3, XC we have calculated as 4. This step is always common, okay, this step is always common, and you just need to have some patience to solve this. 9 plus 16, and trust me, most of the questions from this chapter are very much predictable and you will be able to solve them. Even though slightly tricky in terms of calculations, questions, formulas are, all of them are very predictable. Okay, so this is part A. So impedance comes out to be 5 ohm. What about the current? Current is given by the voltage divided by impedance. Voltage is given here 200 volt. Impedance is 5, so it will be 40 ampere. Okay, so 40 ampere is the current. Now last step is the calculate the phase difference. Phase difference phi is given by tan inverse modulus of, remember this, XL minus XC by R. Okay, remember this, XL minus XC, modulus of XL minus XC by R. Now here again there is no XL, so modulus of minus XC is simply XC. Okay, so it will be XC by R. For this particular problem, it is XC by R. So tan inverse 4 by 3. Now 4 by 3 is a very special value. This is actually 53 degrees. If you don't know it, you can leave your answer over here. If you don't know it, you can leave your answer over here, because you are not allowed any scientific calculator. So either you use a tangent table to find the exact value of this 1.33, okay, or you can, if you know this is very common, 4 by 3, 3 by 4, etc. They are known, well-known angles. But in some cases, if you find some angle which you are not sure and you don't know how to use tangent table, or you don't want to waste time on tangent table, you can leave your answer in the tan inverse stage. You should get full marks. Don't worry, right? So 5 ampere, 40 ampere and 53 degrees. A resistor of 50 ohm, a pure inductor of 250 millihenry and a capacitor are in series in a circuit containing AC source of 220 volt 50 Hz. In the circuit, current leads the voltage by 60 degrees. Find the capacitance of the capacitor. So what is the meaning of current leads the voltage? Current leads the voltage means when you calculate XC, XC should be greater than XL. That's it. Okay, so XC should be greater than XL. So when you are finding the angle formula, what is the formula? I told you tan inverse modulus of XL minus XC by R. This is the formula for calculating the angle. The angle is given here 60 degrees. Okay, but because current leads is given in the question, so instead of writing this, we will write this as XC minus XL. Now XL we have to calculate from the given value, and then using this equation we will calculate XC. So first let us calculate XL. 50 ohm is given, resistance is given, inductor is given 250 millihenry. So how to calculate XL? XL is very easy, 2 pi F into L. Sir, the questions from model paper will come. Yes, it might come. Sir, is it true that most questions for tomorrow it will come from model question paper? Sir, it is in Hubballi. Okay. Yes, correct. The best boy answered them correctly. Rudra, where are you from? I am in Bangalore. Model question paper, some of the questions will be from model question paper, some of them will be based on your question bank, but trust me, the questions that I am giving you are from your previous year questions, pre-board and final board exam as well. Okay, in fact, once we collate all the pre-board papers, we can actually finalize what type of questions is going to come in your board exam. Except the numericals and MCQs, other questions can be understood. Okay, these are the important derivation, these are the important 2-3 marker questions. That pattern is clear once we see all the pre-board papers. There are I think total number of districts are too many, but anyway, I have seen the pattern last year, and we are going to discuss once your pre-board exams are over. There are 2 pre-boards this year, so once both of them are over, we will be able to see a pattern emerging, important questions for your board exam. So don't accept the assume that all the questions are going to come from your model paper, because the paper setter is an independent paper setter, not from your college, maybe not from your college. Okay, generally it's a district board appoints someone to set the papers. He might take some questions from model paper, he might take some question from your question bank, he will take more questions from the previous year questions. That's how the trend is generated. Some numerical questions generally being taken from NCERT, some from previous year, some from question banks. Okay, that's how a paper setter generally sets the question. Okay, anyway, so XL we have to calculate first. XL is 2 pi, frequency is given here as 50 Hz, L is given here as 250 millihenry. 250 milli means 10 to the power of minus 3. Okay, I'm not sure whether it is milli or micro. Anyway, because it's mentioned millihenry, I am taking millihenry only. So 2 pi into 50 is 100 pi into 25 to 50 into 10 to the power of minus 3. So this will turns out to be 25 pi. 25 pi approximately, I think 77. 3.14, 75, 77. 77 point something, let me take it 78. Okay. 78 ohm is XL. Now we will use this. So the phase difference given here 60 degrees, and it mentioned that current is leading the voltage. That's why XC is greater. So tan inverse XC minus XL by R, okay, or XC minus XL by R equals to tan 60. What is tan 60? Tan 60 is root 3, that is 1.73. Okay, XC we do not know, so XC minus XL is 78 divided by 50 equals to 1.73. So XC equals to 1.73 into 50 plus 78. Okay, so it will be 50 plus 35, 85, approximately 85. 85 plus 78. So it will be 150, 163. So 163 is the XC. Now this is not over. You have to calculate the capacitance. Again, I am telling you, don't afraid. The problem is simply easily be solved using your calculators. Only few formulas you have to remember, and all the problems are predictable. So don't be afraid the problem is getting longer. Don't worry, it is not complicated. Only thing you have to use your calculator smartly. So XC is calculated. Next is so XC is equals to 1 by 2 pi F into C. So C equals to 1 by 2 pi F into XC. Now just put the values. So 1 by 2 pi into 50 into 163. So you just need to put the values and you will get the answer. Okay, so it will be I don't know, you have to calculate. You will get approximately 20 microfarad. I'm not sure it is correct or not, but anyway, so according to my past calculation, this will come out around 20 microfarad. Lohit, I mentioned this question, cricket. Sir, it's two most questions for tomorrow model question paper. As I mentioned, cricket and Lohit, some questions will come from. Sir, add this video in YouTube. It is happening in YouTube, Aisha. This is happening in YouTube. I'm not understanding what you are saying. Okay, so just check that if it is 20 microfarad or not. But yes, so 2 questions we have covered all the important theories. We have also covered all the important formulas as well. Exact these 2 questions may not come, but as I mentioned, formulas and concept will remain same. So XC is something which is tricky to calculate because it comes 1 by 2 pi FC. So be careful when calculating XC and try to use the calculator at the last step only once you have sure about everything. Clear? But calculator is must when you are solving alternating current based questions. Now ray optics, an object of finite height is placed in front of a concave mirror within its focus. It forms. So concave mirror, an object is placed in front of the mirror. Okay, so within its focus means this is the focal length. So what will the image it will form? Shreya, yes, this video, in this video I am discussing MCQs and numerical questions. Also I am giving you the other questions that will come from for your board exam, okay, for your pre-board exam. So you just need to solve those questions as well. If you want more detailed 2, 3, 5 marker questions, there is a marathon I have already done. So MCQs, numericals and all 2, 3, 5 marker marathon, if you watch all of them, you should score 55 plus, 60 plus easy. Okay. An object of finite height is placed in front of a concave mirror within its focus, so it will form a virtual image, virtual enlarged image behind the mirror. Okay, so it will be a virtual and enlarged image. Okay, correct answer is when the distance is less than focal length, it forms a virtual and enlarged image. Identify the statement in which is true for a compound microscope from the following. Its objective is a convex lens of greater aperture, its eyepiece is convex lens of smaller aperture, the image formed by its objective is real and inverted, the eyepiece produces the final image which is virtual and diminished. Okay, so remember, in case of a compound microscope, the objective is slightly smaller compared to eyepiece. Objective is smaller, eyepiece is slightly bigger. Okay, the image which is formed by the objective is generally a real image, okay, and real and inverted image. Final image which is formed by the eyepiece is virtual and inverted, same size, and because the intermediate image is inverted, the final image is also inverted, but final image is virtual. Okay, but the intermediate image is always real. The intermediate image is always real. Okay, so the image formed by its objective is real and inverted is the correct answer. And our goal is to make object more enlarged, so eyepiece will enlarge it more instead of diminish it. Okay, so eyepiece will produce virtual and more, even more enlarged image, not diminished. So this is not correct. So this is a very tricky question. Many students fall for the first two options. First two options are actually opposite. A ray of light is incident on a glass air interface at an angle greater than the critical angle for the pair of media. Then the ray undergoes refraction only, partial reflection and partial refraction, total internal reflection, grazes the surface at the interface of the two media. So light falling at an angle greater than the critical angle. Greater than the critical angle means it will only have total internal reflection. If it is exactly equal to the critical angle, then it will grazes the medium. Okay, so if it is exactly equals to critical angle, it will graze. If it is any angle more than that angle, it will always come back to the first medium, so it will be total internal reflection. So total internal reflection. Total internal reflection means no refraction happens, everything comes back. In case of total internal reflection, a light ray must be traveling from rarer medium to denser. Light ray must be traveling from denser medium to rarer medium. Light ray must be traveling to denser to rarer medium. Angle of incidence must be less than critical angle, it should be more. Angle of refraction is 0, it is wrong. Next, a ray of light coming from an object which is incident parallel to the principal axis of a convex lens placed in air after refraction. Okay, a ray of light coming from an object which is incident parallel to the principal axis, okay, of a convex lens placed in air after refraction. So convex lens, parallel rays, after it falls on the convex lens, it will converge, it converges at the focus. Okay, so it will passes through the second principal focus. This is called second principal focus, this is called first principal focus. This is first, this is second. Now why the name is like that? Because we generally consider that object is on the on this side, so this focus comes first, so that's why this is first focal length, and this focus comes second, that's why it is called second focal length. Okay, that's it. Otherwise primary secondary focus is does not matter, it is passing through the second principal focus. Now, what are all the questions you are going to expect from this chapter? Sign convention, the diagram and explanation, F equals to R by 2, total internal reflection, conditions and application as optical fiber, telescope, okay, and a microscope as well. Okay, next is power of a lens, lens maker's equation, refractive index of the prism, refraction at the spherical surface. These are all the important questions. Sir, if I refer this PDF of 2 and 5 marks, can I get 60 marks? If you study everything, yes. Right, sir, may I depend on... I referred chemistry PDF and just got 34 marks of Deeksha. I don't understand, Basava, Raj. Yes, 5C was answer. 5D was answer, not 5D, okay. Parallel ray of light, convex lens, so it will pass at second focus, okay. Nagaraj, not 5C, 5D is answer, 5D. Don't make these mistakes in your exam. That's why we are practicing MCQs as well. Okay, now in the derivation sections, if you are practicing derivation from this chapter, this one is must. If you are skipping this, very good. If you are practicing, this one is must, lens maker's equation. And refractive index of a prism, refraction through a spherical surface if you want to practice more. Otherwise, lens maker's equation is must if you are practicing derivation, and in my opinion, you can skip this chapter in terms of derivation. Now, a small bulb, a point source, is placed at the bottom of a tank containing water to a depth of... give me another 15 minutes, I will wrap it up. Almost done. A small bulb, a point source, is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the radius of the circular surface of water through which light emerges out? Refractive index of water is 1.33. So here we have a tank and we have a water. Okay, small bulb placed at the bottom of a tank containing water to a depth of 80 centimeter. So we have to calculate the radius of the this circle that is formed on the top of this tank. So what is happening first? Let us understand. So here we have a tank water, we have a source. Okay, so what will happen? One ray will go like that, some ray will go like that, and at the end, the last ray that will go will fall with an angle of critical angle. And when the angle is equals to critical angle, then it will pass grazing. Any light which is falling at an angle more than this angle, it will come back. So you will see only this much on both sides of the tank. Okay, so this is how you observe a circular pattern on the water. So if you take a LED torch, put it under some water, okay, you will see a circular spot on the water, because remaining light is totally internally reflected, it never comes out. That's why you see a clear cut circular ring. Now the refractive index is given, okay, the depth of the water is given. What you have to do, you have to find the radius. Now suppose the radius of this radius of this circular thing is say R, okay. So this is say R. Now we know that for sure that at this point this is falling like this. So that means this angle is critical angle. And if this angle is critical angle, then this is an alternate angle, so this angle will also be critical angle. Right? This angle will also be, this is just a geometry. Only thing you have to understand is this angle is critical angle, because any other ray will come back to the tank and will not contribute towards the circle. Okay, so circular pattern that you observe on the top of the tank is because of the total internal reflection. Okay, so this is the only thing that you have to understand. Remaining thing is mostly geometry. Right, so this angle is theta c. So this is R. This is the height of the depth of the water, which is given as 80 centimeter. Okay, and don't convert the units. In ray optics chapter, unit conversion is generally not required. Okay, so 80 centimeter is given. Now this is radius. Now what you have to do, you have to, first thing is you have to calculate sine theta. What is sine theta? Sine theta is perpendicular divided by hypotenuse. Perpendicular divided by hypotenuse. Right? R square plus 80 whole square. Now we also know that for total internal reflection, sine theta c can also be written as 1 by n. Sine theta c can also be written as 1 by n. This is for total internal reflection from Snell's law. Okay, so this also you have to use over here. So 1 by n equals to r by square root of r square plus 80 square. Okay, now what is n here? N is given 1.33. So let us write n as 1.33, and that can be written as 4 by 3. Okay, so this one we will smartly use. So 1 upon n will be 3 by 4. Okay, so let's put that over here as well. So 3 by 4 equals to r divided by square root of r square plus 80 square. Now do the square on both sides. We get 9 by 16 equals to r square by r square plus 80 whole square. Now do the cross multiplication. Do the cross multiplication. 9 r square plus 9 into 80 square equals to r square. 16 r square. Just cross multiplication. Okay, 16 r square. Now just simplification. Take this on the other side. We get 16 r square minus 9 r square equals to 9 into 6400. Okay, or 7 r square equals to 9 into 6400. Okay, now if you simplify this, I think you will get r equals to 91 centimeter. Okay, approximately. So again, you have to use the calculator. You will not be able to solve any question without calculator. In board exam also, the question values are given such a way you have to use a calculator to find the correct value. Okay, I have reduced the problem as much as possible by taking this as 3 by 4. You can use 1 by 3, but it will be 1 upon 1 by 3, and cross multiplication square of that, it might be little complicated. So be smart. If you see that 1.33, sometimes it is easier to use it as 4 by 3. Okay, sir, only critical angle is not interior. Why critical angle is not interior? Don't get your question, Nikhil. Sir, Manju is saying, I doubt someone could actually get 60 plus through these questions only. SKT 071. SKT 071, you should study all the questions that I am giving you, then 60 plus marks is my guarantee. If you don't study, you just came here to comment and go out of the video, then it is not my responsibility. Okay, you will see tomorrow you come in the live and you will see how many students have scored well because of these questions. Okay, if you have studied, if you want to study, that is up to you. If you just want to comment, then that is not my guarantee. Two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of combination. Calculate the power of the two lenses of combination. Again, this question is specifically for pre-board. Okay, this question came multiple times in multiple districts in the past, and maybe it will come in this pre-board exam as well. Okay, this question never came in board exam, but this question did came in multiple districts. Okay, so two lenses of focal length 0.2 meter and 0.3 meter are kept in contact. So what is the expression for equivalent focal length? So equivalent focal length is 1 by f1 plus 1 by f2. So we can say that F equivalent is F1 F2 by F1 plus F2. Okay, so what is F1? F1 given here is 0.2, F2 is given here as 0.3, F1 is given 0.2 plus 0.3. So here we have 0.06 divided by 0.5. So we get this as 0.6 by 5. So if you multiply both sides with 2, you will get 1.2 by 10 or 0.12 meter. Okay, so 0.12 meter is the equivalent focal length. And also, whenever you are solving problem, do not mug the question, especially numericals. Understand the process, which is more important. The process is more important than exactly the same question may not come, but the process oriented questions might come. So be prepared and do not blame that question was different. Obviously question will be different, but this formula, if you remember, that might help you to answer a question. Okay, again, and also you should not make any suggestive deletion. Okay, if you do some suggestive deletion, maybe you will miss out. So that is also one important part. Okay, now what is the power formula is given by 1 by F1 P1. Now remember, power is always in terms of meter, focal length in terms of meter. So here focal lengths are given in terms of meter, so you have to use them in meter only, no change. If it is given in centimeters, here you have to use 100 by F. So 100 by F, you don't need to convert the units, only 100 by F is sufficient to convert it into meter. Okay, so 10 by 2, that is 5 diopter. Okay, 5 diopter is the power 1, power 2 is 1 by F2, again it is also given in meters, so 0.3, that is 10 by 3, that is 3.33 diopter. What is the net power? Net power is P1 plus P2. For power it simply gets added, so 5 plus 3.33, so it will be 8.33 diopter. Okay, so this is the question. So this is the power 1, power 2 and P equivalent. So equivalent, this one I think is wrong. Okay, this one slightly wrong. This will be 0.12 meter. Oh sorry, this is complete different question. This is not the correct answer. Okay, this is a complete different question. Next, wave optics. Let's move on quickly. No disrespect, sir, it's just that I have a lot of trust issues. SKT, if you trust me once, I can guarantee that you will trust me throughout your PU2 journey. Okay, because I know many of you have trust issues. There are some other people, they are teaching, they are saying this will come and it does not come in the exam, and you cry. But you should trust me at least once. At least once you trust me, okay? And then you will realize that what is the difference between our channel and others' channel. Okay, I am also saying that based on your district, there are some chances, some district papers, paper setters, they do set little difficult paper to make you more adapt for upcoming board exam. Okay, but otherwise, the questions that I am giving you today and other fixed questions, already published fixed question, and the 2-3-5 marker marathon series, if you check those along with this, you should be scoring 60 plus. That is my guarantee. Don't I am not saying that you don't trust me. Just trust me once. Okay, you have one more pre-board. Trust me now. You fail, you appear for the second pre-board, right? So you have one more chance. Just trust me once, then you will see the difference. Okay, Sanjana sir, our college, they were discussing that they won't conduct second preparatory. Is it mandatory or not? Sanjana Gowda, it is not mandatory. Okay, second preparatory is only for those who will fail in first preparatory. So maybe in your college they will conduct it for select students, those who have failed, those who did not score well in first preparatory, because preparatory marks goes into the record, right? In your record of annual record of your entire career. The preparatory board marks are also recorded. Physics is not that important. Mathematics, English and Kannada, they are important, right? So maybe if you do not have that much number, then they will might conduct for a select students. Okay, so and question paper will be set by your district. It will be coming to your college as well. So they will might give you directly, say you have already scored well, you don't need to appear for it. So second preparatory is not compulsory, but best of the two will be considered. The shape of the wave front for light coming from a distant star. Nagaraj already answered. I see it's 1C. Plane wave front. Yes, for a distant star, the light waves that is coming is plane wave front, because they are considered parallel. Parallel rays are actually giving you plane wave front, right? Next. Sorry, my screen hanged. Give me a second. So principle of superposition of waves applies whenever one source of light falls on a screen, one source of light move across a screen, two or more sources of light illuminate the same point, two or more sources of light illuminate two different points. So what is the answer? Sir, chemistry tara only 1 mark and 5 mark. My chemistry got very bad. Is it possible to come back again? Yes, Nikhil, it is possible. You can come back if you start again fresh, then you can come back. Okay, stay connected with us. We are going to start your pre-board marathon, final board marathon series from next month. Right now, also you can check your previous videos that we have done in your channel. Okay, you should always improve. You should always look for improve. You should not get disappointed by one result only. One result should not make you disappoint. Okay, you should always strive for more. Okay, so two or more sources light illuminate the same point. Yes, Nagaraj, again you are correct. Now next is, we will have constructive interference if the path difference is delta x equals to n lambda, delta x equals to n plus 1 lambda by 2, delta x equals to n plus half lambda by 2, half lambda, delta x equals to n minus half lambda. Constructive interference, not destructive. Okay, I don't understand, Manjunath, what you are trying to say. Chemistry, they are only 1 mark and 5 mark. What is the meaning of that? Pakirapa Barikeru saying option C. Why are you saying for this previous one? Okay, now this one, yes, 3a. So the path difference is delta x equals to n lambda, direct integer of n lambda. Okay, and n plus half lambda is generally for destructive interference. Okay, n plus half lambda for destructive, or n minus half lambda generally is considered, because for destructive interference it starts from n equals to 1. So there, that's why it is n minus half lambda. To observe diffraction, the size of the obstacle should be lambda by 2, where lambda is wavelength, should be order of the wavelength, has no relation to the wavelength, should be much larger than the wavelength. What is the answer? Quickly, Nagaraj saying 3A, 3A is correct. 4, question number 4, quickly. Question number 4, to observe diffraction, the size of the obstacle should be, it cannot be less than lambda first of all. Second of all, it should not be very large. It should be maybe 2, 3, 4 times, 10 times than lambda. So it is called order of the wavelength. Okay, the gap should be of the order of the wavelength. It should be order of the wavelength. It should be multiple of the wavelength. Maybe 2 times, maybe 3 times. It does not necessarily to be integer. It can be fraction, but it should be more than lambda. Okay, so it should be of the order of the wavelength. Order of the wavelength means 2 times, 3 times, 2.5 times, like that. That is called order of the wavelength. Next, 2 lights each of intensity I0 are used in Young's double slit experiment. The intensity of interference maximum is, intensity of the interference maximum. What is going on? My screen is frozen again, sorry. Is B, okay, not lambda by 2. Okay, lambda by 2, it cannot be less than lambda. Okay, Nagaraj is saying 5D. Tanesh is saying C. Okay, let's see. Again, intensity of the intensity maximum in case of Young's double slit Young double slit experiment is given by 4I0. Maximum intensity is given by 4I0 and minimum intensity is given by 0. Okay, if both of them are same intensity, okay, then the maximum intensity will become 4 times, minimum intensity will be 0 times. The average intensity is 4 plus I0 plus 0 by 2, that is 2I0, that is I0 plus I0. So average intensity is basically adding up of the 2 intensities, but maximum and minimum is basically more and less. So it is actually reorients the energy. The energy is not creating, energy is not destroying, it is actually rebalancing the energy so that average energy still remains same. Intensity is a measure of energy, right? Now what are all the questions going to come? Huygens principle, conditions for maximum and minimum, coherent and incoherent sources of light, diffraction of light, Malus law, uses of Polaroid. Uses of Polaroid is one of the most important question from this chapter. Laws of reflection using Huygens principle, laws of refraction using Huygens principle are the important derivations from this chapter. Okay, so these are all the important questions. Now let's move on to the next. Dual nature of radiation and matter. Let's answer only MCQs quickly. The de Broglie wavelength of a moving particle is independent of dash of the particle: charge, mass, speed, momentum. So de Broglie wavelength of a moving particle is independent of the particle. So lambda equals to h upon p. What is p here? P is momentum, that is mv. So what is it is independent of? It is independent of, let's see who can answer. Independent of, so lambda is basically h by mv. So it depends on mass, it depends on velocity, it depends on momentum. Okay, so it is independent of charge. So it does not depend on charge. Next, the process of emission of electrons from a metal surface by applying high electric field is called, so electric field is called thermoionic emission, photoelectric emission, secondary emission, or field emission. Name is easy. The name suggests easy. This one, Nagaraj, 1A is correct. 1A is correct. Question number 2. Question number 2. Quickly. Let me finish it quickly. Let me help. 2C. Field emission. Yes. Electric field, field emission, heating, thermoionic emission, light, or wave, electromagnetic wave, photoelectric emission. Secondary emission is nothing, it is actually something related to Huygens principle. Okay, thermionic is heat, photoelectric is EM waves, field emission is electric field. Next, in photoelectric effect experiment, the graph of physical quantity Y versus a physical quantity X is a straight line passing through an origin. Then Y is photoelectric current and X is collector plate potential, Y is photoelectric current and X is frequency of the incident radiation, Y is stopping potential and X is frequency of the incident radiation, Y is photoelectric current and X is intensity of the radiation. So what is the question first of all? So basically they are talking about some graph where the graph is a straight line passing through the origin. So what could be this graph? What is the y-axis of this? What is the x-axis of this? This is y-axis, this is x-axis. What could be this graph? Okay, so there in photoelectric effect there is only one graph where it is passing through the origin. Okay, and that is basically, this is your photoelectric current. And this is intensity. Okay, so photoelectric current and intensity of the incident radiation. So option D is correct. Y is photoelectric current and X is intensity of incident radiation. Okay, and remember the incident frequency has to be greater than threshold current. Yes, 3D is correct. Nagaraj, javelin thrower, came back and answered is correct. Macroscopic particles in our daily life do not show wave-like properties because they are not associated with waves, their wavelength is extremely high, their wavelength is 0, their wavelength is negligibly small. Okay. What happened? Why someone is so many comments? Hi Surya. What is option? Question number 4. Macroscopic particle means big particles that can be seen in our normal eyes, naked eye. If you can see something in our naked eye, they are called macroscopic. Microscopic means if you need a microscope to see, they are called microscopic. Small objects, very, very small. Okay, for example, electron is a microscopic, proton is microscopic, but you, me, cricket ball, bat, okay, football, they are all macroscopic. So why they are? Yes, Nagaraj and javelin, not javelin thrower, Dharmax answered it correctly, and Nigaya Hiremat, okay, Nigaya Hiremat also answered it correctly, option D. Okay, the wavelength of matter wave is known as Einstein's wavelength, threshold wavelength, de Broglie wavelength, Newton's wavelength. What is the answer? Easy question. I am not waiting for the answer. I know more, you know the answer. It is called de Broglie wavelength. Okay. Now let's see the important questions from this chapter. Experimental Leonard-Horlbach observation. Now remember that experimental observation of photoelectric effect, Leonard-Horlbach observation of photoelectric effect, okay, or simply Leonard observation, simply Horlbach observation, all are same. Okay, so this is basically experimental observation, Leonard-Horlbach. If you study this question, actually different varieties of all experimental observation based question are actually same one. Okay, answer is same. Einstein's explanation of the observation and Einstein's equation. Okay, Einstein's equation and explanation combined, these two actually sometimes can be asked as a 5-marker question, sometimes not according to the latest blueprint, but maybe your pre-board may not follow exact blueprint, so you might get a 5-marker question. Otherwise, explanation and equation both you have to study. Definition: photoelectric effect, threshold frequency, work function, stopping potential, all definitions are important, and graph based question. Okay, graph based. What is the graph? Draw the graph for say 3 different frequencies having different stopping potential. Okay, so the graphs are also important. See the graphs one by one. Next, atoms and nuclei together, 5 MCQs from both chapter combined. total energy of an electron revolving in nth orbit of hydrogen atom is least for, total energy is least, that is smallest total energy for n equals to 3, for n equals to -1, n equals to 2, n equals to 4. So not -1, n equals to 1. What is the total energy? The total energy expression is given by E equals to minus 13.6 divided by n square. So smallest total energy. 5C. Okay, 5C was correct. Now next, answer this. Javelin thrower is saying 1. Yes, 1. So more negative is smaller. Okay, so if you put n equals to 1 over here, that means you will get the most negative value. Most negative is smallest. Okay, so total energy of electron revolving in the hydrogen atom minus 13.6. That's why it is called higher energy orbit. If you see that, always you say ground state and higher energy state or excited state. Excited state means it has more energy than the ground state. So that's why it is called higher energy state. So n equals to 1 should have the least energy. Next, the minimum energy required to free the electron from the ground state of an hydrogen atom is 0.85 electron volt, 3.4 electron volt, 13.6 electron volt, 1.51 electron volt. Manjunath is saying 1D, not 1D. Higher the orbit, okay, higher the energy. They are asking least. Least means smallest or lowest. Okay, lowest is only when n is lowest. Okay, direct relation, you can remember it. Okay, smaller the n, lower is the total energy because of this negative sign. Only because of the negative sign, the higher the n, okay, higher the energy. Now next, this question number 2, C. Prakash, Nagraj, javelin thrower, everyone answered C. Yes, I am not going to explain. This is also called ionization energy. Okay, if you see a question based on ionization energy, the same answer. Let capital K be the kinetic energy, capital U be the potential energy, and E be the total energy of the electron revolving around the nucleus in hydrogen atom. Then which of the following is correct? K greater than 0, U greater than 0, E greater than 0, K greater than 0, U less than 0, E less than 0, K greater than 0, U less than, greater than 0, E less than 0, K less than 0, U less than 0, E less than 0. K is kinetic energy, U is potential energy, E is total energy. So which one of them is correct? So remember that K is kinetic energy. What is kinetic energy? Kinetic energy is half mv square. So m mass of an object cannot be negative. Velocity, even if it is negative, the square of the velocity cannot be negative. Square of any number is positive, right? So kinetic energy can never be negative, and it is true for all objects, not only for electron revolving in the orbit. It is true for all objects. Kinetic energy of any object is always positive. It can, the smallest value or kinetic energy can have is 0. Smallest energy it can have is 0, that means it's static. Otherwise kinetic energy cannot be negative. You learned it in your first PU, maybe you have forgotten. Now for any electron which is orbiting around the nucleus, okay, it is stick with the nucleus. That means its potential energy has to be negative, its total energy also has to be negative. So K is greater than 0, U is less than 0, E is less than 0 is the correct answer. So option B is correct. Now let's move on. Yes, 3B is correct. The nuclear force is attractive for distance r equals to 0.5 Fermi, attractive for distances less than 0.8 Fermi, repulsive for distances greater than 0.8 Fermi, repulsive for distance 0.8 Fermi. Answer. Very interesting question. This question came in the past. This question came in one of the previous year paper, and many students make mistakes here. Okay, the nuclear force is, if you remember the graph of nuclear force, very interesting actually. Okay, the graph comes like this. Tasniyata Basum, you have to join the WhatsApp channel. You can check the pinned comment in the live chat. The link of the WhatsApp channel is given there. All the note links will be shared. Okay, clear? Tasniyata, Tanil Nair, got to out it. Javelin thrower is saying B, Nagaraj is saying B. Attractive for distances less than 0.8 Fermi, no, B is incorrect. Check on the pinned comment. Check the pinned comment. There the link is given. After this lecture is over, the notes will be shared again once more. Okay, it is already, previous notes are already shared. If you want to get the notes along with this lecture, it will be shared again. Okay, so remember that this is around 0.8. This is 1 Fermi and this is about 2 Fermi. Okay, so remember that distance, any distance less than 0.8 Fermi, the nuclear force is repulsive. From 0.8 it becomes attractive, it becomes maximum around 1 Fermi, 1.2 Fermi, and then again it goes to 0 around 2 Fermi. So the entire thing happens from 0.8 to 2 Fermi. Okay, so nuclear force is strongest force, but also it does not allow anyone to come too close. Okay, the nucleons want to say, okay, you are, I will attract you, but you have to stay outside my boundary, that is 0.8 Fermi. So beyond 0.8 Fermi it is repulsive. Okay, from 0.8 around 2 Fermi it is attractive, and after 2 Fermi it becomes 0. Okay, so repulsive for distance less than 0.8 Fermi is correct. Okay, so this is the graph. This means potential energy is positive. Positive potential energy means they repel each other. Negative potential energy means they attract each other. Okay. Next, the nuclear radius of the order of 10 to the power of minus 6 meter, 10 to the power of minus 8 meter, 10 to the power of minus 13 meter, 10 to the power of minus 15 meter. Answer it. One more chapter we have to complete quickly. So nuclear force is of the order of, nuclear radius is of the order of 10 to the power of minus 15 meter. This is called 1 Fermi or 1 femtometer. Okay, 1 Fermi or 1 femtometer. Okay, this is the smallest unit of length. Fermi or femtometer is the smallest unit of length. Okay. Sometimes don't be confused, this is also 10 to the power of minus 13 centimeter. So if the unit is given in centimeters, it will be 10 to the power of minus 13. If the unit is given in meters, it will be minus 15. Okay, that's why they try to confuse you by giving minus 13 here. Minus 13 centimeter would be correct, minus 15 meter would be correct. Now, what are all the questions? 3 postulates of Bohr atomic model, limitations of Bohr's atomic model, energy orbiting electron in hydrogen atom, de Broglie's explanation of second postulate, binding energy and mass defect and related numericals, features of nuclear force. Features means properties of nuclear force, nuclear fission and fusion, difference between them, their definition based questions might come. Okay, so these are all the important questions from this chapter. Last chapter, semiconductors. Let's complete it quickly. Sir, how to get model paper answer notes done by you? This is also shared in the past. I will ask our administrator to share the link for model paper. I have done model paper 1, Aditi may have solved model paper 2, model paper 3 we have not done, but model paper 1 and model paper 2 are already available. That link also be shared today. Please check, keep an eye on our WhatsApp channel. P-type semiconductor is electrically positive, negative, neutral. As temperature increases, it becomes negative. Let's see. Nagaraj answered this correctly. Neutral. Okay. P-type semiconductor or N-type semiconductor or intrinsic or extrinsic or PN-type semiconductor, PN junction diode, they all are electrically neutral. We just imbalance by adding an impurity which gives out extra electron, and itself becomes a positive or itself becomes a negative ion, okay, but total charge will always be 0. So that is, it is always electrically neutral. In an intrinsic semiconductor at room temperature, the number of electrons and holes are equal, 0, unequal, infinite. Intrinsic semiconductor. Yes, Pakirappa, Nagaraj and Nagaraj and Pakirappa both answered correctly. Next question, the intrinsic semiconductor. Intrinsic semiconductor means number of holes must be equals to number of electrons, okay, and intrinsic density is given by Ni square is NH into Ne. Okay, this is, if you are preparing for any competitive exam, remember this formula, not for tomorrow's exam. Okay, so answer is equal. 2A, Nagaraj answered correctly. When a PN junction diode is in forward bias, which type of charge carrier flows in the connecting wire? So you have a diode, you have forward bias state. Forward bias means P side is connected to positive, N side is connected to negative. Now this is the connecting wire, this is the connecting wire, this portion is connecting wire. What current is flowing in this connecting wire? What current is flowing in this connecting wire? Winter Luna is saying 2A, okay, 2A was correct. 3D, free electrons. So wires will always have electrons. Electrons will always travel from negative to positive, okay. So electrons will always travel from negative to positive, but we do not consider the direction of electron. Current is considered in the opposite direction of motion of electron. So remember that in conducting wires, holes does not move, only thing that moves is free electrons. Next question, a positive hole in a semiconductor is absence of free electrons, an artificially created particle, an anti-particle of electron, a vacancy created when an electron leaves a covalent bond. So what is the answer? D. Yes, it is a vacancy. Don't fall for the trap and mention absence of free electrons. It is a vacancy created when an electron is actually leaving a covalent bond. Okay, absence of free electrons are not holes, by the way. Last question, the energy gap in case of which of the following is less than 3 electron volt but greater than 0? But greater than 0. The energy gap in case of which of the following is less than 3 electron volt but greater than 0? Aluminium, iron, germanium, copper. Sir, if I study previous year question paper, will it be enough? No, no, no. Previous year paper is only one paper. Okay, even if you study all the 3 papers, may not be sufficient. If you study all last 5-6 year papers, yes. Okay, not only 1 year will not sufficient. Tansiata, I answered your question. Stop spamming. Prasidh, Samarth, Nagaraj, everyone is saying option C, germanium. Yes, this is aluminium. For it, the band gap is 0. Band gap is 0. Band gap is less than 3 electron volt but not 0, but greater than 0. Okay, this is also 0. Okay, so these 3 have band gap 0. Germanium, it is less than 3 electron volt but greater than 0. Okay, now what are all the questions going to come from this chapter? Band theory of solids, energy gaps and diagrams, intrinsic and extrinsic semiconductors, p-type and n-type semiconductor difference. Important question, biasing of a diode may become full wave and half wave. Okay, that's super important question. And if you want the solution for this full wave and half wave, and you also want to revise the entire physics in quick, less than 30 minutes, do come tomorrow morning at 5 a.m. I will be publishing one video for all of you, 30 revision under 30 minutes. Don't miss out on that. There all the important questions, the doubt that you might have will be covered as much as possible, all important videos. I'm not discussing entire syllabus, obviously 30 minutes is not possible, so there I will be discussing all the important questions, so don't miss out on that, and do join us for that. And please let me know how was your physics exam. Tomorrow also I will be coming live with the paper discussion for Bangalore South, so do come and join me and let me know how was your paper. Okay, this is the end of this lecture. Sir, provide important questions, answers please. Rahmanullah, there is a 2, 3, 5 marker a marathon video already published where all the answers are provided. Do and go and check that out. PDFs are also available in our WhatsApp channel. You can download it. This entire PDF will be again available to you after this lecture is over, right? So please, everything is already done. Harshita, that's why I'm here live, doing live. Can you do mass defect numerical? Mass defect numerical, okay, let me see. I have solved few mass defect related numerical. Give me a second. Give me a second, let me find. If I can find some question, I will solve. Give me a moment. Sorry, I cannot find any mass defect based numericals. So what you can do, yes, it will be added to the channel. Harshit, what you can do, you can check my atoms and nuclei Brahmastra. It is already published. There I have solved mass defect based numerical questions as well. You can go and check that out in Brahmastra series, atoms and nuclei combined chapter. Nuclei comes after atoms. So at the end, around end of the video, you will find some mass defect based very important 2 or 3 questions I have done. So do check that out. Okay, I cannot find the PDF of that, otherwise I would have collected and I have solved it, but unfortunately it is not here. Maybe I have recorded in some other studio. Binding energy, again binding energy, mass defect, same thing. Okay, the formula, if you want I can write down the formula. Okay, formula is mass or total mass of the nucleons. Okay, m proton into number of z plus number of neutron times mass of neutron. Okay, the masses of the neutron and protons will be provided in the question, so don't worry about it. Multiply them neatly, then minus the mass of the atom, that is also provided in the question. That is the total mass defect. Now mass defect times c square is the binding energy. Now you, instead of multiplying with c square, what you can do, you can multiply 931.5 MeV. That will give you the binding energy in MeV. Okay, that is the binding energy. Now divide that with the total number of nucleons to get binding energy per nucleon. Okay, so calculate the mass defect first, that is number of protons times number of mass of proton, number of neutron into mass of neutron, add them, subtract the mass of atom. Mass of atom will be less than addition of these two values, and then whatever defect you get, multiply with 931.5. okay, you can check that out in our can you say some confirm question for preparatory? Harshit, I have discussed in this entire lecture all the important questions. There is a confirmed fixed question video, 15 minutes video, where all the important questions for all the chapters are discussed. In this lecture also I have discussed. Okay, you can go and check that out, the fixed question video where all the important questions are discussed. Okay, bye Nagaraj, I am done. Okay, so you can check that. Okay, Harshit, all important questions solutions, everything is done. The specific that one you have asked, the binding energy, I have solved in atoms and nuclei. Brahmastra, you can go and check that out. Okay, they are not super difficult. If you practice 2-3 problems, you should be able to answer them. Okay, and also bye everyone. It was already over 3 hours. I have to close this live,